Welcome, everyone. First, I'd like to respectfully acknowledge that we are on the Center for the Ancestral, Traditional, and Unceded Territories of the Tsetien and Bottleneck peoples. And thank you all for participating in our meeting today. Challenges to our future tree seed supply. We're involving quite a few You're going to have to help me.
Technical difficulties already.
As we're waiting for that, I'll introduce myself. I'm Dave Kolotelo. I'm at the Provincial Tree Seed Center. I've been working in this area for about 30 years. Don Piggott, another co-organizer here. If you don't know Don Piggott, you aren't involved in the tree seed world, so I think he goes without saying. Melissa Spearing, she's at the National Seed Center and seed biologist, and Victoria Lee, she's our testing supervisor at the Tree Seed Center. So we're the production team for the meeting. If you have any questions, anything you need answered, help with anything, please see any one of us and we'll help you through the process. This is working now. Okay, we have a wide range of groups that we decided to meet, and we all have really a common theme, really the sustained availability of high quality and adapted seed. That's really what we're moving towards. Certainly some of these groups that I've been involved with, participation and activities have diminished even before COVID. So we're really trying to bring these groups together, see if there's some synergies, some ways we can help each other, because we all have very common goals. We've had many in-kind sponsorships. I would like to point out two in particular, Select Seed and the Vernon Seed Orchard Company for their generous financial donations. So thank you very much. Many others throughout the program will be recognized for their in-kind contributions, but in terms of meeting organizers, cold hard cash very much is appreciated, especially at the beginning of the meeting. PNW conifers, I'll make no apologies, but this meeting will be very much conifer focused. We are in the Pacific Northwest. Others of you who are dealing with other tree species, I encourage you to put on tree seed meetings and extend the information that you have. Certainly in British Columbia, we will be conifer dependent forever, but we will be expanding our use of broadleaf species, and we'll be looking to others and their expertise that they've developed. I know there's some risk in putting up slides like this because I may have forgotten someone, so I apologize if I have. I'd like to point out just a few people. Each one I could talk 5 or 10 minutes about, so I'm just going to mention their names. Dr. George Edwards, Ben Wong, Rick Sheffield, Frank Bernard, Heather Rook, and John Russell. So what are our challenges? I see they're multi-pronged. Can that black thing disappear there?
Yeah, so let more people into the room.
As you can tell, Melissa is the technology person on our team. So what are our challenges? Certainly facility closures, and one of the biggest things that draw several of us together was the closure of the Ontario tree seed plant, and their sort of giving away genetic resource management and opening it up, not providing cone and seed processing services. And we have a few people here who used to work there. In terms of British Columbia, we used to have a very active cone and seed processing business. We had 6 processing facilities, and now it's basically yellow point propagation in our facility. And so we really have much limited capabilities at present. There's been a lot of rapid succession, lots of practical wisdom, and that's where a lot of the knowledge comes from in our industry. It's not something you're going to learn in school. So we lost a lot of knowledge. And I've talked to people over the last couple of days, and my impression is we have a lack of interest and motivation. And this may not be a global phenomenon, but certainly we have trouble attracting people into this business. And how can we change that? Can we make that more attractive? Is there something we can do in terms of educational components or making it more attractive as a research study? That I think often seed services are taken for granted and the understanding of our role isn't understood. I paraphrase a colleague, we're often operating behind the scenes and seed services are only noticed when they fail. And this goes on to whether it be condensate processing, collection timing, or stratification practices. I think there's a lack of research and education, and I think there's a very strong link between these two. I think a lot of the research funding is going towards newer technologies. We're digging deeper, and I'm not against any of those technologies. I don't think there's just a fair distribution of available research monies. So picking the latest, sexiest tools rather than the most appropriate tools, even if they're very low tech, sometimes is the most appropriate tool. So I find we're in this very, this cycle, no funding, no research, no people, no teaching, no progress. And how can we get out of this cycle? Another one of our challenges is capital investments. To operate a fully functional seed center, there is capital investments. We are dealing with different times. There are different safety pressures. And we're often talking about this farm versus industrial model. I don't think one is wrong or right, and there's room for both. But times are changing. One of our biggest challenges is moving the slide forward. All right, so many of you are familiar with all these big promises for tree planting in terms of carbon sequestration or other needs. Many of these are focused on plants and nurseries, and seed is often an afterthought. And so I think the whole idea of seed biology isn't getting as much attention as it should. I think this is my personal slide on some of the things I think are bottlenecks. I think we do have a lack of people working in the area of reproductive biology. We have been fortunate in BC, University of Victoria. We've had Dr. John Owens, Dr. Patrick Atterkis, who are really leaders in this field, but I have a hard time finding anyone in North America who's actively working in this area in research. If anybody knows of anybody, please point them out to me. In BC, we also have a history of past downsizing efforts, basically eliminating all the physiologists. And that was a tough decision that needed to be done at the time, but I'm very surprised we haven't picked up the slack in that area. We're so dependent on our seed orchard practices and our improved seed. It's such a huge investment, and we don't have crop physiologists that are working on that. And we're also looking with climate change, more physiological traits, drought resistance, stress resistance. Physiologists have a prime role to play. The second real bottleneck I see personally is really in terms of extension gaps. Again, we're going higher and deeper into research, and this gap between research and operations is widening. And I often call it the Grand Canyon. So I think we need extension and technical exchange services more than ever. Certainly some advancements are not shared. So I think there is a need for public practical research. And again, I'll emphasize the low tech is still important. And again, loss of practical hands-on experience, and as everybody's experienced globally, labor is a big issue. There are some good initiatives. I hope you're familiar with this paper, Challenges to the Reforestation Pipeline in the United States. It's quite a good review, and you'll see there are quite a few seed issues that have come from the forefront. So they are recognizing seed as a very important part of the reforestation pipeline. As we move through, and sort of just to give you our BC perspective, this is kind of the area I work in, the seed handling system, from basically cone handling after collection up until delivery to the nursery. In British Columbia, the testing, registration, and storage components, those are considered stewardship activities. And so the province delivers those to the owners of the seed, and they're required to store the seed at our facility at no cost. The rest of the area is open for competition. We perform cone and seed processing and seed pre-treatment on a cost recovery basis. I always emphasize the 3 I's as I look through this system: identity, integrity, and information. And those are really key as we move forward in our programs. So back to our sort of common goal. How do we ensure the sustained availability of high quality and adapted tree seed? You know, what can we do? How can our various groups help each other and develop synergies? Can we somehow sustain the enthusiasm and effort once we all go back to our jobs? I'm sure all of us have been in meetings and get all excited at the meeting, and then you go home and you get into the drudgery of your job. How do you keep some of the enthusiasm and energy going? I don't know. How do we expand our scope beyond the have nations? And you know, many of our organizations are looking to expand into these other areas of the world because we're dealing with global problems. How do we do that? We've had one idea within our group, and if you can tell me tonight whose quote that is, I'll buy you a beer. If you get it wrong, you buy me a beer. So what we're thinking of doing is we want to develop some simple 2-page white paper to convince politicians or other funding organizations the importance of our tree seed environment and the lack of investment needed for research, education, and extension activities. Through the day, I hope, and online and through other means, we've asked 5 main questions, and you'll see them on the backboard there. Please put your comments down on them. You know, what is your highest tree seed research priority? What is your biggest concern with tree seeds? What is your biggest tree seed extension information need? What is your most critical infrastructure need to secure your required tree seed supply? And what tree seed information is critical to have in courses dealing with trees and forestry? It's just 5 questions. Please forward your own. Part of our meeting this morning is really building relationships. So we are going to do a round the room sort of introduction. Please state your name, your tree seed interests if you like, and your organization that you're affiliated with. And what do you want to get out of this meeting?
Pass the mic around then. Online can hear. Want to go first?
Sure. Hello, my name is Sean Webb. I work at Arbutus Grove Nursery. I've been there for 20 years. I enjoy growing trees and I enjoy sowing seeds. So just networking and meeting everybody involved in the industry.
Corey Matheson, Mount Newton Seed Orchard, Mosaic Forest Management. Been working there for about 8 years now. And yeah.
Yes, hello. My name is Øyvind Edvardsen. I work for the Norwegian Forest Seed Center. I also represent the International Seed Federation's Tree and Shrub group on this meeting. I used to be a manager for 15 years. Now I'm the seed manager, so I'm more on the operational level now. So yeah, interests, seed technology in specific now, and also this is a good place to be with networking, get to know people.
Hi, I'm Don Piggott, Yellow Point Propagation. I've been in private business for 40 years this year, and slowly sliding towards retirement. And I'm more interested in extension communication and gene conservation.
Hello, my name is Sarun Khadka. I'm graduate student from University of Alberta. I'm Dr. Thomas grad student, and currently I'm working on nursery operation on genetic diversity of seedling by using this high throughput phenotyping. And yeah, I'm very much interested in seeds. I did my bachelor thesis also in this seed of hardwood species in Nepal. And I'm really looking forward to gain more knowledge and experience from this meeting. Thank you.
When you guys speak, if you just hold the microphone a little farther away, just for people online, you can talk to everyone.
Can everyone hear me? Michael Post, I'm manager of the Provincial Tree Seed Center here in British Columbia. Been involved in various jobs at the Seed Center since 1995, so over 3 years. Took a brief break, worked for some different ministries in government. my interest really is networking and meeting people here today. And also one of our challenges is getting capital funding, getting some new equipment, reinvigorating the Tree Seed Center, and really interested in learning about other tree seed centers, the equipment they use, whether it's storage, processing, testing, just keeping the Tree Seed Center going is one of our big objectives, and we'd like to see it continue for the next 60 years. We did celebrate 65 this year, so we want to make sure it's around for the next generation and for the trees we're planting this year to be harvested or enjoyed by the public, whatever the value of the day may be. Thank you.
Hi, my name is Sue Woodall. I work for Weyerhaeuser. I've been there for about 30 years, and currently I am the seed operations team leader there, and took over for Greg Fancher when he retired recently. So good to be here.
Good morning. My name is Greg O'Neill. I work at the Kalamalka Forestry Center in Vernon, where hopefully we'll see many of you folks in a few days. I work in the area of climate change adaptation, and I'm interested in all things seed and climate.
Hi, I'm Chelsea. I work for Weyerhaeuser. I am relatively new to this side of things. Previously, I was a regen forester down in Washington, so I've had some experience in orchards, but getting to go out in the woods and do seed collections out there, and just excited to hear more about what you all do.
I'm Tia Wagner. I work at Vernon Seed Orchard, which produces seed in an orchard. And we are just starting an extraction facility. So my interest is mass accumulation of knowledge, as always.
Yeah, thank you. Brian Barber with Select Seed. And give a presentation later. You hear about what the company does. I've been involved in tree improvement seed related work for about 30 years. And looking forward to continuing the knowledge acquisition and networking and meeting some new people today and next week.
Hey, I'm Kevin Astridge. I'm the Tree Seed Policy Officer for here with BC Ministry of Forests in Victoria, maybe for the last 3 years. And prior to that, I took seed for granted for 20+ years. So, so this is part of, figuring out what happens behind the curtains, and yeah, looking forward to talking to people about seed.
Hi, my name is Sheila McCartan. I'm the Science R&D Manager at Meland Forest Nurseries in Wales. Prior to that, I was the tree seed scientist at Forest Research for 15 years. I'm interested in all things tree seed, everything from seed science and technology to the impact of climate change on seed orchards and seed supply.
I am Nicolas Feau. I'm a research scientist since 1 year at the Canadian Forest Service and a forest pathologist too. I am presently at the CFS as a project that is funded by the 2 billion tree program, so federal funding on seed pathology in collaboration with Dave. And I'm looking forward today to learn a bit more about the seed world and connect a network.
Hi, my name is Gwilym Blackburn. I'm the national focal point for forest genetic resources based here in Victoria. And so I'm new to seed breeding and rearing. I'm very fascinated to learn about it. Ex situ conservation is one of Canada's chief strengths, as I see it so far, in forest genetic resource conservation. And so I'm happy to be working with the colleagues I've met so far and interested to meet more of you over the next day.
Good morning, everybody. My name is Sabina from International Seed Federation. We are based in Switzerland, and we like to see ourselves as a kind of voice of the global seed industry. So we are dealing with mostly field crops and vegetables, but we have a small seed trees and shrub group who are meeting here. Yesterday we had our annual meeting, and about ISF and our activity, Øyvind will give a presentation soon, so you will learn more. So I'm very happy to be here and learn from you.
Thank you. Yes, so my name is Johanna Gårdebrink, and I'm from Sweden, working for the Swedish state forestry, Sveaskog, and I'm working as a seed specialist and mainly responsible for the seed storage that we have and managing.
My name is Roger Törnqvist. I work together with Johanna at TSWG in Sweden. I'm in charge of the tree seed production center as well as the seed orchards within our operations, which is around 100. To me, this business is a lot about being humble, learn from our success and mistakes, and best practice within the industry.
Hi, my name is Victoria Lay. I'm a testing supervisor at the Tree Seed Center. So if you've ever used moisture content, purity, seeds per gram, germination values, that's come through our lab. I'm mainly interested in learning more about the operational side. I find working at the Tree Seed Center fascinating. Sometimes we call our lab the fishbowl just because there is glass and, you know, all our stuff is very small scale, but it has such a big impact. I want to know more about the impact.
I'm Ryan Sheffield. I'm with Sheffield Seed out of New York State. I've only been working in the industry for a year, so I'm just trying to take in as much as I can and learn everything along the way.
I'm Bouvet, also representing Sheffield Seed Company. I'm responsible for procurement of the company. Been in the industry for over 25 years. Part here with the ISF group, and just very eager to hear about what a lot of other people have to tell about the future of our industry.
Hi, I'm Helen Richardson. I'm from the United Kingdom, and I've been at Forest Art for 24 years, and we supply tree and shrub seeds to primarily into the UK, and also we import and export seed as well. And again, just want to find out what everybody else is up to, really.
Hi, I'm Dave Richardson. I love this industry so much, I married the boss. I joined Helen 15 years ago in the business. My special responsibilities are finance, investment, and our R&D pipeline.
My name is Dean Swift, and I've been supplying seeds from the Southern Rockies, Arizona, New Mexico, Colorado, and South Dakota since I graduated from college in 1971, 51 years, self-employed.
Alternate geography, also self-employed. I started Seed the North 3 years ago. We collect, process, and enhance seed, focusing on the northern geographies based in Hazelton, BC. Really interested in the intersection of increasing quality of seed genetics as well as soil science, and how that can help reforest and restore northern landscapes at a really large scale. I'm going to bring the microphone. Yeah.
So, hello, I'm Edvardsen, and I came from Czech Republic, where I have small seed business. And I'm interested to see the differences in the seed work in Europe and in BC. And I'm interested in the origin of populations.
Good morning. My name is Steve Kiskala. I'm at Arbutus Grove Nursery, and we'll be going there later for a tour after lunch. I've been working in forest nurseries for over 25 years, and seed's the most important thing for us to grow a successful crop. If we don't start with a good seed, yeah, it's all downhill from there. So I'm just interested in learning more about seed storage and how we can improve germination and seed disease, and just, yeah, all things seed that can help us grow a better crop. And like Dave said, we're growing about 18 species right now, but 17 are conifers and 1 maple. So then we sowed 15 million cavities this year. So, but we're just a medium-sized nursery in BC.
Hi, I'm Sarah Gravel Bisgold. I'm from Somerville Nurseries in Ontario, Canada.
I've been there for 4 years. I'm an assistant grower looking after the seed source, supply chain, and everything, doing it at a nursery. Prior to that, I was at the Ontario tree seed plant for 16 years before its closure. And I'm just interested in networking with people and talking more about seed and processing.
Hey, my name is Sigrun Sigurjónsdóttir and I'm from Norway. I'm a wife to Øyvind, but I'm also working as a forest advisor for the last 25, 30 years in Iceland and Norway.
I'm Pat Martin. I work here in BC in the provincial government. I'm the director of the branch that includes the tree seed center, the orchards, our breeding programs. So I'm not a technical specialist. I'm a sort of a senior manager.
I'm Eleanor Morton, and I work at the Alberta Tree Improvement and Seed Center. So my main job there is to look after all of our reforestation seed. I store it, register it, ship it, lots of it to BC. Our program, we have a tree breeding program with seed orchards, and we follow along. Our routine is the same as what BC does with their tree orchards. And I'm always just, I'm here always looking for more ways how to improve our seed storage, that seed, and just everything on the ways of handling our seed. And I've been with that seed. I've been at it for probably at the Tree Improvement Center for a very long time. And we won't say that because it's really a long time, close to one up there. So anyway, thank you.
Hi, I'm Lise van der Mave, and I am a research scientist at the BC Ministry of Forests, and I work at a capstone for getting a chance to touring, hopefully most of you tomorrow afternoon. And
My name is Sabina Donnelly. I am the seed research specialist in the Forest Improvement and Research Management branch. I have the pleasure of working with clients to help them pick climatically suitable seed. My goal is to get clients to pick the best seed meeting our reforestation objectives.
Hi, I'm Marilyn Cherry. I'm the Cone Seed Operations Officer at the BC Tree Seed Center, and I oversee cone seed processing and inventory management. And basically, I'm looking forward to networking with everyone.
I'm Peggy Popel. I'm with Smoky Lake Forest Nursery. I also I'm the seed plant manager for our cone extraction and cleaning facility in Alberta. And I've only been doing this for 4 years, so I'm relatively new. So I'm excited to learn more and see what everyone else is doing.
Hi, I'm Ben Alexandrowitz with Silva Seed in Washington State. I'm a fruit seed grower and I also run the seed extractory, cone and seed logistics, drying and cleaning.
Thank you, everyone. That didn't really put us behind schedule. We're almost on schedule. We have a great meeting ahead of us, and we're going to move ahead. I hope it encourages other people to hold tree seed meetings and sort of extend this communication. And I know people are comfortable with the people they've come with in their own groups, but I really encourage a lot of mingling during the day, during our evenings, during the day to learn things about others. So first off, we thought we'd give an introduction of all the groups that are here. And the first one is the International Seed Federation. And Øyvind Edvardsen from the Norwegian Tree Seed Center is going to give an overview.
Yeah, I'll just put that on here. So not so it doesn't.
Yes, good morning, everyone. It's very good to be here. As I told you, I work at the Norwegian Forest Seed Center, and we are actually the only seed facility in Norway. In Norway, we plant about 50 million seedlings a year. I will also represent ISF as Tree and Shrub Group as the chair of the group. So that's what I'm going to tell you about now in this short presentation. So ISF is a non-governmental, non-profit making organization, and it increases recognition of its members' contributions to food security and sustainable agriculture. And ISF likes to recognizes itself as a voice of the global seed industry. So important task for the ISF is to facilitate for free movement of seeds, and within the framework of fair and science-based regulations. Establishment and protection of intellectual property rights is important. Rules for trading seeds. ISF also provides settlement of disputes through mediation for members. It is an organization with a long history. As ISF is today, it's 20 years old. It was merged of two organizations, the International Seed Traders Association, where the Tree and Shrub Group were incorporated, and the International Plant Breeders Association. So in 2 years, it's actually 100 years old from the start of the Seed Traders Association. The Tree and Shrub Group dates back to about 1964. And it was established to set rules for trading seeds internationally. ISF is a big organization. It has 58 national seed associations as members within 75 countries. And in that, it's 7,500 plus companies represented. Tree and Shrub is a very small part of that, but not less important, not less relevant, because of the world's needs of more forest, more trees. This is a really important group within ISF. We have today 22 active members from Europe, India, Australia, US, China, New Zealand. You can see here we have Austria, Australia, yeah, China, Czech Republic, Denmark, France, Germany, Hungary, India, Ireland, Netherlands, New Zealand, Norway, Russia, Spain, Sweden, UK, and USA. We really miss our Canadian colleagues, so please reach out for us if you find this interesting. The kind of members within the Tree and Shrub Group are everything from small family businesses to foundations or state-owned national seed centers. So it's a huge variety in the kind of businesses. And that is a good environment for discussions. The Tree and Shrub Group, it's a special group within the ISF. As I said, it was established in '64 to agree on trade rules for business. When it's a special group, it means that it has its own governance. But we are, of course, obliged to comply with the articles of association and internal rules within the ISF. We have annual meetings and those are organized by the members of the host country in consultation with the chair of the group and the secretariat. And we also have a travel fund, so we can allow members of the group to represent the tree and shrub group in meetings in the OECD, EU, etc. And we also have designated the delegates that go to OECD meetings to follow the work that's being done there, and also share the view of the seed industry. And we recently have designated a contact point to a new EU Horizon project. So this year we are a relatively small group, 9 members. But usually we are on meetings 20, 25 members. This picture is from a couple of years ago, 2018 actually, in Lillehammer, where my company was hosting. And a typical meeting is a 3-day event with an optional 1-day excursion. We have our business meeting. We have presentations from the host country, scientific talks, and excursions. But also very important, networking. Get to know the people that you actually dealing with, and get to know what happens around in Europe when it comes to seed trade and obstacles that may occur. This year we choose to team up with this event. We thought it would be good to have the possibility of networking with all the people here in this region. Next year will be in Sweden, and after that in 24 we will try to have a meeting in New Mexico, and then it's France. But you see, we have meetings from all over the world, China, Europe, North America, mainly, yeah, where we have our members. So main topics on the agenda is horizontal ISF issues that have relevance for our group members, market access issues, regional and national seed and plant health regulations that impact seed trade, development of the phyto system, seed crop informations from the members is important, working on maintaining quality in the seed industry, getting updates from the international organizations like OECD and ISTA, and information from the members toward the table, that each member give information about developments in the seed and plant business in the country. We also have taken positions on, especially on trade barriers recent years. The EU directive on forest reproductive material, it's the ISF position that this directive must not be merged with other EU directives, because today it's very much the same information as in the OECD certificate, and then it's easy to trade. We have made a position paper to the European Commission regarding regulations around the Gibberella cystonata fungi. We have also advocated the need for scientific-based national regulations on use of provenance and seed sources, especially in climate change context. And recently, EU regulation establishing a professional high-risk plant and plant product list, and there's been an industry lobby effort to exclude tree seeds from this list of high-risk plants. Otherwise, it will be an import ban also for tree seeds. So it's important to have organization that actually addresses issues that are relevant for everyone in the trade. Yes, I think I've stayed within 10 minutes. So thank you, everyone. Yeah.
We're just going to move ahead with the program, and then we'll fill in with the ISTA video later.
Try one more. Before moving to CFA to work in Saskatoon Seed Lab in 2000.
So I'm going to be providing a talk, basically 3 of the groups that are involved in the meeting today. Thanks. The Tree Seed Working Group, it's our main host group, and it's basically Melissa and I are the Tree Seed Working Group. Many of you receive our news bulletin. If you do not, I think it's a worthy piece of extension regarding tree seed. It's free, you receive it electronically, and we really appreciate all those people who contribute to the news bulletin. We think it's a really great complement to kind of the refereed scientific journals. It extends information on sort of a folksy level, and it's an opportunity to also share your failures, because that's the way you learn as well. The other group, it will be the IUFRO group, 2.0903. I'm coordinator of that group, Seed Physiology and Technology. It's been a very inactive group as of recently, and we're trying to revitalize that group. We have a big history in Canada with several people, George Edwards, Ben Wong, Thomas Beardmore, being really spearheads behind that organization. And last, our International Seed Testing Association, Steve is going to give the introduction of ISTA as a whole, and I'll be talking about the Tree and Shrub Committee. So the Tree Seed Working Group's been around since 1983. We are a part of the Canadian Forest Genetics Association. Yeah. We have really 4 main objectives, and these really haven't changed since the beginning. Seed research from bud initiation to seed use, the identification of seed problems related to tree improvement and forest management. It is under the umbrella of our Canadian Forest Genetics, used to be the Canadian Tree Improvement Association. We want to encourage the exchange of information on seed-related problems and advise on implementation practices. So it's just our efforts in terms of knowledge transfer and extension. We have a very specialized field. There aren't a lot of people working in it, and we want to just increase communications between people. And it's really, as I said, an important complement to the referee journals to extend practical information, knowledge, retirements, whatever. We're a very open source in terms of format of material that we put in. It just has to focus on tree seed, and that really is our core scope. I mentioned we put out the news bulletin. All of the past news bulletins, all 72 issues, are available on our webpage. So I'll ask you to please contribute. And if you aren't a member, you can see Melissa or I. For those of you from BC who don't know, species, please. You don't get a beer for that one. And we try to put on workshops at all of our biannual Canadian Forest Genetics Information Association meetings, and just some fun pictures from some of our past meetings. IUFRO. IUFRO gave me 20 slides to promote their organization. I selected 4 or 5, and I'm not going to go through them in detail. I think most people are familiar with the International Union of Forest Research Organizations. It's a big It's a big organization. It's founded in 1982 and it's based in Vienna. It's really advances, its main mission is to advance research excellence and knowledge sharing, fosters development of science-based solutions to forest-related challenges. Some of the key themes: forest for people, forest and climate change, forest and forest-based products for a greener future, biodiversity, ecosystem services, and biological invasions. And the last one, forest, soil, and water interactions. Most of the working groups that we would be involved with would fall in Division 2, Physiology and Genetics. And there are some current task forces on the go. I was quite interested to find this and certainly very interested to speak with anybody who's involved with it. But the bolded one there, strengthening Mediterranean nursery systems for forest reproductive material procurement to adapt to the effects of climate change. So quite encouraged to see that as a task force within IUFRO. In terms of our specific group, the office holders are myself, Petri Häminen from Finland, and Elisa Vieira from Brazil. I give Sheila an honorary membership there. Sheila's our past coordinator of the group. She established our blog, which hasn't been very active, but was used as well for organizing the meeting. As well as the tree seed working group, we are trying to expand our distribution list to expand our knowledge of who is involved with the tree seed field. The main aims are to provide a forum for discussion of forest tree seed problems and their solutions in both temperate and tropical forests, and exchange information on forest tree seed physiology, particularly in relation to seed dormancy and seed technology, which include processing, stratification, storage, and testing. And what are we doing? Well, my activity has been mainly organizing this meeting. Last year for IUFRO World Day, a few of us put together a kind of fun video just to encourage participation. It all starts with seeds. There's a link there if you haven't seen it. It's also in your program. It was very fun to do, and another woman from Brazil did a great job animating and editing it. One of the key things on our website is we have all of our proceedings going back to 1973, where the first meeting was held in Bergen, Norway, and the topic was seed processing, and we'll actually be reaching the 50th anniversary of that. I don't know if that requires something or not, but I've never been to Norway. And we have all our past newsletters. We were no longer publishing them, but they went from 1973 to 2008. So there's 73 editions. And lastly, our ISTA Forest Tree and Shrub Committee. Elisa Vieira is our coordinator, and Vic Vankus is kind of second in charge. I've just stolen all of these slides from Elisa. She's just presented our, and she's online, so she knows that. From her meeting, our annual meeting of ISTA that just took place in Cairo. So just a map of the world to see the distribution of members, very European focused. We are looking for, a global representation, so certainly looking for participation from Africa and South Pacific. A few things that we are working on: validation of germination test methods for African mahogany. This is a species that is not in the ISTA rules that is being planted widely. So we haven't secured the seed for this yet, but that's one of our activities. The second one we've been working on is, I guess, trying to update, make electronic this fairly old guidebook that came out in 1991, describing the rules. It's black and white. There was a few color pictures, and there was an effort before where we had a handbook of seed testing and nursery practices in association with the OECD, and that's still online at that link. It's very incomplete. Our ISTA committee decided, we are not experts in the nursery system, and it varies so much throughout the landscape. Let's just focus on our seed testing aspect. So that's what we've done. We're going to, from the updates, remove the nursery components and with the hundreds of species, we really wanted to start at the genus level. So we're going to be dividing those 74 genera that fall into the tree and shrub category, and basically try to fulfill it. It's be very pictorial. One of the needs that a lot of people have indicated, especially in the testing realm, is identification of abnormal seedlings. So there's been a lot of emphasis on that. And certainly our committee welcomes others to contribute to the committee. There is a formal process to become a committee member. I think we do have one opening in our committee, but people are very welcome to contribute. And one of the other things ISTA does, they provide a lot of training around the world, most of it agricultural focused, but a lot of the seed testing principles are applicable to a wide range of species. So they put on really good training. Obviously the ISTA rules, most of you are familiar with, and Seed Testing International, the latest version actually had conifers on the cover, so I can't complain about that. And that's it for me.
I know it didn't work because you turned the audio right off, so I'm gonna try it.
Do you want to go? Yeah, go with Steve. Where's your mic?
Okay, we're gonna try Steve's video once more. I think I know why it didn't work.
Hi, welcome to the Future Tree Seed Supply meeting. I'm going to give you an overview of ISTA. My name's Steve Joel. I'm the immediate past president of ISTA. I've worked in the UK for over 30 years before moving to CFIA to work in Saskatoon Seed Lab in 2008. Later this year, I'm retiring from the CFIA, but I will continue to work on the ISTA committees. From 1988 to 1997, I was a tree seed researcher at the UK's Forestry Commission Research Centre, now in Salt Farnham, a period of life that's dear to my heart. And I've managed to continue to work with the tree seed community by being the liaison to the ISTA Forestry and Shrub Seed Committee. I've also had more recent close contacts with Dave Kolotelo and Melissa Sparing, and I want to continue in that work in retirement. I'm speaking to you from near Saskatoon, from the Treaty 6 land and home of the Métis. If you're ever in Saskatoon, please do look me up. Agriculture is important in Saskatchewan, and that's where my focus has been for the last 14 years in Canada. But not so far from us is the start of the boreal forests, and it's a wonderful adventure to go up to Prince Albert National Park, just a few hours north of us. But this talk here today is about ISTA. So what is ISTA? ISTA is the International Seed Testing Association. It's a global not-for-profit association of seed testing labs and individuals with members in 84 countries worldwide. It's really a technical association, but operates under the governance of member countries and distinct economies. ISTA's objectives are to develop, adopt and publish standard procedures, and also to promote research in all areas of seed science and technology. The four pillars of ISTA are the international standardization of methodologies, the reporting of those results, and the way that they're standardized in laboratories using proficiency testing and accreditation, as well as the dissemination of knowledge. One of the main publications of ISTA is the International Rules for Seed Testing, ISTA Rules. The current edition is the 2022 edition, and new editions are effective every 1st of January. Annually, there are updates and improvements, and some changes have just been voted on by the ISTA membership at their meeting in Cairo. Within the ISTA rules, there are 73 tree shrub genera covered and many more species, as well as specific chapters for tree seeds, like excised embryo and X-ray. There are other chapters that have specific methods for tree and shrub testing in them: sampling, purity, other seed species search, germination, including the weighed replica test, 1000 seed weight, tetrazolium, as I already mentioned, excised embryo, X-ray and moisture. Chapter 2 of the ISTA rules is free download, and that has maximum seed lot sizes in it, sampling methods and sample sizes. And the tree seed genera and species that I mentioned are all listed in table 2C of the ISTA rules. The complete ISTA rules are free to all ISTA members, and some chapters like chapter 1 on certificates and chapter 2 on sampling are free to everyone. ISTA certificates are something that you might have heard of, the Orange International Certificate or the Blue International. The orange is the main one that ensures traceability from maximum seed lot size to sampling to testing. The blue is only about testing and not sampling. OECD seed schemes broke the link between the need for the ISTA Orange certificate in the 1980s and 90s, and it meant that some governmental laboratories stopped testing or weren't involved in ISTA because of that. But there still are at least 22 labs accredited to test on tree seeds and issue Orange International certificates if the need is there. The main aim of ISTA, when it was formed in 1924, was to facilitate the trade of seed around the world. And with that aim in mind, ISTA has continued to standardize and maintain its uniformity in seed testing. The ISTA Executive Committee helps manage the association, and the 11 members are shown here. The Executive Committee over the last 3 years has really been a virtual event, but the first physical meeting was just recently in Cairo. The ISTA Executive and other technical committees have continued to work during this period by making use of virtual tools. The main work of ISTA is achieved through the 20 technical committees. Most technical committees or working groups have at least 15 members from all over the world and different disciplines. Heads of the technical committee chairs, the heads of the technical committee chairs are shown here. ISTA's publications include the International Rules for Seed Testing I've just mentioned, method validation reports to support changes in the ISTA rules, the ISTA pest list, which shows which pests may be transmitted by seed, the ISTA handbooks, of which the seed sampling one has recently been published, Seed Science and Technology is the journal for ISTA, and twice yearly there is a Seed Testing International magazine, which is available for free download from the ISTA website. Accreditation is one of those other things that ensure uniformity in testing, and since 1996, ISTA has got a quality assurance program to accredit seed testing laboratories worldwide. Now there are 145 ISTA accredited labs, and 22 of those can test tree seeds. For germination and for other methodologies, maybe a few less. But this is in 19 countries worldwide. But there's not a huge number of people testing tree seeds, or indeed testing seeds at all. Every 3 years, the ISTA accredited labs are audited to maintain their accreditation status, which means there is about 50 ISTA audits every year. Young at ISTA is a focus just recently for ISTA. With the changing demographics, we need to attract young people to seed testing, analysis and research. There's a LinkedIn forum, and the younger people can also access ISTA technical committee work, and is looking to support travel to ISTA meetings. Also with free publications in the Seed Science and Technology journal, and to support training at ISTA labs. Indeed, the first seed symposium for the last 3 years will now be in November in Athens, and perhaps you'll be able to attend that. I just need to wish you all very well for a great meeting there in British Columbia. Sorry I can't be with you, and thank you for listening. Take care. Bye.
Brian's currently the CEO of Select Seed, the executive manager of the Forest Genetics Council, also president of our Canadian Forest Genetics Association, past director of our former tree improvement grant.
Thank you, Dave. Thank you, Melissa. Can you hear me in the back? Okay, great. And thank you for those joining us online and those taking the effort to come to visit beautiful British Columbia. Thank you very much. You hit the weather just right. And let's hope that lasts for the next few days. I'll get right at it because we're behind schedule, and you will see some of this in action over the next, or the afternoon and in the next couple of days. But Dave has asked me to give you some background about seed production and use in BC. I'll touch on that as well as give you some of the context within which we're producing seed in British Columbia, so you have an understanding of our system. But why do we have seed orchards in the first place? And it's because we grow and plant about 300 million trees per year in British Columbia. Over the last couple of decades, 3-4 decades, we've planted over 9 billion trees. So that equates to thousands and thousands of kilograms of tree seed. To be able to produce those seedlings in a timely and manner, et cetera, in a high quality, we need a stable supply of tree seed of high quality. And so that's where the tree seed orchards come in. But I'll give you a little bit of a background of tree improvement and seed production in BC, talk about our organization, the policy framework within which it operates, and so then give you some stats on our seed orchards and seed production and use. I'll just touch on climate-based seed transfer and some of the tools that we've developed, but I'll leave the details for our speakers later this morning, and I'll touch on some of the current challenges and future opportunities. So tree improvement and seed production really began in the early 1950s at the Cowichan Lake Research Station, which some of you will be visiting tomorrow, with the first geneticist, Dr. Eleanor Ewing. And legend has it that Jerry Birch, the chief forester for BC Forest Products, showed up on a Friday night with a bottle of rum because he'd heard Alan was interested in starting a tree improvement program, but he didn't have any money. So Jerry rallied the industry, and together they organized what they call Plus Tree Weeks, which they identified some of the phenotypically superior Douglas fir, and that was the beginning of the Douglas fir program. At the same time, people like Mike Marr and Bruce Devitt went about and established some seed production stands to provide some seed supply for the growing reforestation program and nursery programs. So that led to the formation of the coastal and the interior tree improvement councils and the expansion of seed orchards in both the coast and the interior. Rules changed, and forest companies were responsible for planting the areas that we harvested. So there was a lot more investment in nurseries and planting, and also the introduction of seed transfer guidelines and registration requirements. Into the 20s, we got reorganized with the revamping of the Forest Genetics Council, and then a decade ago, another change in government, new rules, and the introduction of new chief foresters seed use standards, which I'll touch on. And then of late, of course, we've been all dealing with climate change and how do we get best seed on the site. So we've have the introduction of climate-based seed transfer, as well as potential use of genomics tools. So brief history there. Who organizes or how kind of coordinates all this? It's under the auspices of the Chief Forester Council. It's appointed by the provincial chief forester, some reps from industry and government, supported by some technical advisory committees that provide advice on priorities for breeding, new seed orchards and funding, coordination, communications, etc. We have a 5-year strategic plan, and that sets out some performance measures, like including select seed use. Interesting, we've got an interesting construct. I run a company that is owned by the Forest Genetics Council, and the mandate is to actually produce tree seed for reforestation in BC, and then also provide some support services back to council. So you can go to our website and learn more about that. Division of responsibilities in BC. The ministry does the breeding. They're in charge of the policies, the tree seed center. The forest companies themselves have got to, they're responsible for reforestation. That includes all the cost of planting, including the purchase of tree seed. And they will pay contractors to grow those seedlings in nurseries like we'll see today at Arbutus, and they also pay contractors to plant those trees. Select Seed, I mentioned we've got orchards that are under contract with other companies. And then the seedling nurseries, they've got contracts with companies and government. Was asked to touch on the tree seed regulations. So Sabina's got more time to talk about the tools later. But under the Forest and Range Practices Act, if you are harvesting crown timber, you have an obligation to reforest with a commercial tree species and in a timely manner. And if you're going to be planting trees, then you've got to grow those trees with seed that have been registered, tested, and stored and used in accordance with the Chief Forester's seed use standards. Those standards require that seed have be collected from at least 10 trees, or in a seed orchard have an effective population size of 10 or more. So that means most of our seed orchards have about 30 to 40 unrelated parents in them. The numbers vary depending on the orchard, the species, but that's a way of maintaining genetic diversity in the seed lots that are used to grow and reforest our forests. As Dave mentioned, all that seed is all registered, tested, and stored at the Tree Seed Center, and all the information is posted on the seed planning and registry system. There are purity and moisture content requirements to store it there. And then when it comes time to selection, persons must use orchard seed over wild stand seed, and that's to ensure that the province realizes the investment that's made in tree breeding and in the seed orchards. Otherwise, people may opt to use less expensive wild seed. And furthermore, when they're planting those trees, they have to put the seed in an area where it's adapted climatically, and those transfer limits are prescribed in the Chief Forester standards, and Greg will talk about those climate-based seed transfer rules there. Of note, their government does not interfere with the seed pricing, but they are considered a bit of a price leader. They post their prices online, and you can see those on the website. Okay, now to the seed orchards. These are the delivery system for BC's tree improvement program, and it encompasses maybe 13, maybe 14 species now. There are 93 active seed orchards in the province with over 100,000 trees in them. They're located on 17 sites, and I've added Don Pigot's new site up on the Coquihalla Highway to that list. And these orchards are managed by both the ministry and private companies. 14 of which 14 of those orchards are managed under contract or partnership with Select Seed. Most of these orchards are located in warmer, drier locations. Like there has been a consolidation of the orchards on the coast. They're located here primarily on the Saanich Peninsula and in the Okanagan Valley, northern Okanagan Valley, which I hope some of you get a chance to go next week. But there are 3 orchards in the far north and 1 in the far south. The reason for that is the warmer, drier condition, more conducive, more regular crops. We're finding in the north in particular, the spruce crops were not appearing for, or they were appearing every 10 to 15 years. Moving to the hot, dry Okanagan, you get a spruce crop every 2 to 3 years. We haven't found that has worked so well with pine lower seed sets, so that's why we're moving our pine orchards north. Again, production, as you know, in seed orchards is quite variable from year to year. Spruce is quite prolific. It constituted about 63% of the 2020 crop, and the other main species there are listed, but you can see big swings in the production. The average genetic gain for all the orchard seed is about 20%, and that equates to about 20% more cubic meters of wood available for harvest. That's 60 years for coastal Douglas fir, but 80 years for all the other species. In terms of the demand for seed, I mentioned we're about 300 million trees planted in BC each year. There's the list of the species, and the big 2 species in the interior are interior spruce, Glauca anglemania, and lodgepole pine, Pinus contorta, followed by the coastal and interior firs, and then western red cedar, larch. Those are the big, called the big 5. And most of the coastal Douglas fir and the spruce seed is all derived from from our seed orchards, but we're only about 42% of lodgepole pine. That's because we're in the North Okanagan, too hot, too dry for the northern population. So another reason for moving our orchards north. So this is a collage of those orchards being established in Quesnel and Prince George over the last couple of years, with the graphs being supplied by the Ministry of Forests at the Kalmaka Forestry Center. I touched on that. A big focus of late, though, is not producing trees that are fast grower, but also are more resilient or tolerant to pests and disease. And so there's a lot of effort going on in that area. So you'll see some of that on the tours later. So I won't spend a lot of time on that, nor will I spend a lot of time on our new climate-based seed transfer rules, because Greg O'Neill's going to describe that. But to highlight that, because of the change in the deployment area for seed orchards, it's really changed the demand equation. And so we're figuring out what that means in terms of our orchard needs, in terms of the gaps and the opportunities for new orchards. And we inform that discussion by trying to figure out how much seed people will need in the future. Harvest in BC is declining, but then we have these bigger fires, and we have government programs that are coming along to rehabilitate these denuded areas. So a bit of the dynamics going on there, but we've got a tool that now can compare what the demand is in the future out to 2049, and then compare that with our updated seed production forecast from our orchards. So we'll use that to look at the gaps. So there's a new tool online that everyone can look at and see what orchards are producing for their areas. So the challenges of late, well, of course, we've all been dealing with COVID, but a lot of attention to worker health and safety. So we didn't have any major outbreaks. Big effort, particularly in the planting community, to bring people from all over the country into BC to plant these trees and keep the workers and the community safe. As you've probably heard in the news, we've had quite a number of years of significant wildfires, and that's had adverse impacts on our air quality. Fire came very close to the PRT Armstrong Nursery the PRT Armstrong Nursery north of Vernon, and that site was evacuated last year for a couple of days, but fortunately no damage done. We have shortages of seasonal workers in like a lot of industries. So there's that, plus changes in pesticide use and regulations, and then back to where do we need to go in terms of our orchard capacity. But our opportunities include promoting forest genetics and tree seed as part of the climate crisis solution by producing trees that are healthy, adapted, and resilient to climate change, and can store more carbon. We can use genomics to shorten our selection process to speed up, keep up with the changes. In terms of labor, we've got the temporary foreign worker program. More people are taking advantage of that, as well as getting more First Nations involved in the operations. We're looking at ways of extending the life and the height of our orchards, using lifts, etc., and then getting up a little higher into the crown by using drones, which it hasn't really been operational, but we're looking into that. And then, of course, the sharing of information, and the COVID has actually been, of course, promoted the sharing of information through virtual conferences, so we can have hybrid meetings like this where we have people in the room as well as online. So a quick run through, hopefully that'll give you some context and information about what you're going to be seeing over the next week or so. And I encourage you to just reach out at any time, but I probably went over time already.
But Ryan, you can give a plug for next summer if you want to. Next
summer. Okay, well, actually it was pretty close to 15 minutes there. So next summer is the Canadian Forest Next Association meeting. Is that what you're talking about? Yeah. So we just kind of settled on a date and a location for the Canadian Forest Genetics Association and Western Forest Genetics Association. It will also be back in Vernon. That'll be a scientific conference, but we will, be promoting tree seed at that meeting as well. So encourage you, if you can't make it up to the meetings in Vernon next week, then look for the details for next year. Okay, thank you.
Meland's experience. She's the budding seed scientist at the National Tree Seed Center, leading her master's right now. After Melissa's talk, we'll have a break. I'm going to go make sure catering is in order and see what's up with our missing speaker from this morning. So we may not be that far behind schedule.
I think we're doing good. Okay. All right. Okay, so thank you, everybody. So yeah, I'm from Fredericton, New Brunswick. I also do some sort of hybrid jumping back and forth between central Canada and New Brunswick, but I've been working for the Canadian Forest Service now for about 2 years. And as the new kid on the block, I get handed files and told, you need to figure out how to do this from the guys that left and retired. So I've been sort of handed and given the OECD file to help with reporting. And it's been a very interesting experience just to get involved with OECD. I've been following ISTA for a long time. Those of you that might know Dale Simpson, the former manager, was kind of the first person that introduced me to it. And I kind of thought it was an interesting thing to work on. So I'm just going to try and hide the chat. There we go. So for those that don't know or those online, so OECD it's been an international group that's been looking at harmonized certification rules for seed moving and trade. There's 2 that Canada has signed up to, and a lot of countries in the world are signed up to. So the big one obviously is agriculture. It's been around since 1958. In Canada, it's supported by our Federal Seeds Act. So it controls varieties and protects consumers for, that it's the proper variety of canola that someone guarantees. And then we have the second one, which is for basic and improved trade of forest seeds and plants, which was established in 1967. Canada joined in 1970. Because of our federal and provincial jurisdictional responsibilities, we don't have a federal Forestry Seeds Act, but the provinces all control what seed gets used on provincial land, like Brian just explained. So there's a big, agriculture is it's a huge amount of volume that goes into it. And as Øyvind said, tree seeds are a little part, but still an important part. So OECD participates a lot with ISF, ISTA, and this new union of protection of varieties, especially in agriculture. But the whole thing is to bring the whole supply chain together. So breeders, distributors, producers, ultimately just to benefit everybody. So forestry is the same. Change. What happened? Sorry, 1 second. There we go. So there's currently with the forest seed scheme, there's 30 members. Recently, the UK, Bulgaria, and Slovenia have joined, and so there's a small budget that the group in Europe has, and so the country's all dependent on, there's a base fee and an economic GDP calculation. So Canada pays about 7,600 euros for us to be a part of it right now. And how it worked in Canada was that the CFS the Canadian Forest Service is designated as the authority, and we have 5 main offices that would have spread us out across the country if there was equal activity in all those regions. But as most things do, it boils down to where is the most number of producers. So the Pacific Forestry Center in Victoria is where most of there was a lab there up until 96, until the ISTA certificate portion was taken off, but the reporting all happens at Fredericton. So we're kind of on 2 coasts just to try and cover everyone. If there was a pickup of activity, it would mean that a forestry officer from any one of our offices would be trained and shown how to do it. So I found it extremely beneficial for where I'm at my career, just to be on the virtual meetings. There's so much knowledge that's in those groups. So they were all virtual through COVID. Again, new members that apply, they're still very much welcoming any new countries that want to participate, trying to get a little bit more representation, farther afield from just the EU. but it is mostly EU members. And there's been a few small changes to the rules. They haven't changed a whole lot since I think the big update was in 2004. But there's a few new definitions, and they're more and more recognizing advanced technology and advanced breeding programs. And then we continually adjust for the seeds coefficient so that we can take kilograms of every species reported and convert it into numbers of seeds. There was a provisional summary from 2019 to 2020. So it runs from June 30th to July 1st. That's the sort of fiscal year for seed trade. So the last time there was a report, 21 out of 30 countries reported. There was a total of 3.7 million kilograms of tree seed produced either internally or traded between or by members. Importation has gone down as most countries become self-sufficient, which is great. And there's a small amount of export. Unfortunately, just because of the transition, we had two really key long-term people retire at the exact same time. So we weren't able to report in this year. We were still trying to track down information. But we have the information now. We can always submit it retroactively. But it's highly dominated by the EU scheme. But the interesting thing is just, for Canada, there's still important volume by weight for red oak, but it's all produced in Europe. And Douglas fir obviously is #1 for seed requests still, or for exports, sorry, imports. It's a lot of tables. And lots of things that are really interesting about OECD is just there's all these other discussions about technology around certification, around communications, around guidelines that help all countries sort of work on the same principles. So some of the proposals that have come through in projects that they want to try and fund just beyond the rules include these new scannable anywhere in the world tags and a system that anyone with a label can tell where it's been. So very much about the traceability components. Recognition more now of biochemical and molecular techniques to certify provenance just beyond the piece of paper. Communications just to promote the use of this continuing mixing of seed lots to recognize genetic diversity. And there's all these really interesting projects that people have mentioned already. So the ISTA OECD handbook, the Formatus database, which controls or is a place to register a lot of these materials. And then, this sort of genetic conservation strategy in Europe. So what OECD, I think, ultimately always wanted was that the scheme would be the guidelines and every country would set up their own regulations. So there's a really great presentation in May this year just to show where Germany's at with their forest reproductive system. And they've essentially decided a couple of years ago that they were no longer going to even encourage just plain source identified seed. They want orchard qualified and tested material used on all public land. And they also have I believe it's a contract with a company that's doing all of the biochemical tests for certification of provenance based on genetic markers. So they've got a full complete system nationally, and then they can also use it for trade back and forth, but it really does control now their production process in country. So some of the things that I've been learning as the new person is all the things that we're supposed to do in Canada and just trying to keep them up to date. One of the main things that national authorities have to do is maintain this catalog of approved materials. The catalogs all used to be printed online. Increasingly now they're available in open source. So I could go take a driving tour of Europe and visit every seed orchard if I wanted to, because the map's online. So we've been able to digitize ours, just internally, so I can look and see where every stand that Don Pigot's ever driven to probably is. And it's great to have that information. Some of the stands may not have been visited, but it's an era of climate change, and keeping old records, even if you don't have a seed sample anymore, I still think is really important once they have good geo coordinates. So there's some small new updates to certificates and labels just to make it easier for everyone to compare information. The tags have 10 fields. The certificates and the paperwork have 20 fields plus signatures. So they're supposed to align with your database for anybody having a question later about why something worked, didn't work, whatnot. And it shouldn't be too onerous for people to use this, even interprovincially. It was encouraged in the 80s that we should adopt this between our provinces and jurisdictions for trade, and that may come up again. But most of the fields in there are what people use for seed registration by most of the important provinces that plant a lot of trees in Canada. So the graphs always look a little dismal, but you know, OECD had its height, and the demand really from the EU for Pacific Northwest conifers was really in the, you know, the 70s and 80s, and it's been steadily declining because they're producing their own. In the last few years, there's been just a few certificates, primarily of coastal Douglas fir issued, and you know, but on average since 2007, we still can export about 200 kilos a year. And if it's high value, I don't look at the weight. I think that it's worth people's time and effort, and if it's desirable, then that's why we continue to support it. So we are also, when we go to do the annual reporting, we're supposed to report seed that also left the country without an OECD certificate, just to get a sense of the trade balance. So from July 2019 to March 2020, we still exported 8,600 kilograms of tree seed from Canada to various places. The biggest amount is ABs going into the US. One thing that's challenging, and because I just got this data set about 2 weeks before, we were trying to build a query to pull this information from the Canadian Food Inspection Agency, because they at least track things going across the border. So the challenge I see is sometimes on the paperwork for people that don't know about OECD, they don't put the full species, so you only have the genre, and it makes it kind of difficult to, I can't report like that. So we're going to work more with CFIA the next little while to try and understand the data set better and how things are moving as they are. And if you guys want to ask me questions about this, I can pull it up a little bit more in detail. Because ultimately for reporting, what they'd like to do is have this, there's a system online where everyone that's a member can log on. You can see everything that Canada exports in a summary table. We're still doing it a little bit the old way in the forest seed scheme. It's still an Excel spreadsheet you have to fill out, but ultimately the goal is to have statistics tracked in a much more regimented way. And of course, you know, CFS sees the charts of demand and says, why are we still doing this? But, you know, there's some indication with climate change, with biodiversity, if there's any need, again, for a certain type of, you know, Douglas fir, if it's not just wild stand, but now it has to be seed orchards, is there still an opportunity? How does CFS help people? What systems make everything easy to do? So that, you know, if you want to sell a little bit of seed to the EU, that we're doing it by the scheme we signed up for. And, you know, I think more often that I'm seeing it discussed in those meetings is that countries are now using it more to control for this mass awareness of assisted migration and climate-based seed transfer as it becomes operational. So there's 2 research projects we've been advising the foresters on that are CFS. They are research projects, but they're large operational programs planting about 200,000 trees. There's 2 assisted migration projects, one at the Petawawa Research Forest, where a map using seedware, especially trying to find pitch pine seed from the eastern seaboard, has been recommended. So they're trying to do a 100-year trial with doing things business as usual, then trying different seed sources and populations. So we recommended that they use the OECD guidelines in the certificate to ask all the commercial suppliers from the States to at least keep that information with us long term. So when they go to do their analysis, they haven't lost the original information where that came from. It's also in the eastern US. There's been a lot of closures as well from public seed orchards and nurseries. So there's increasingly just more nurseries selling seed that haven't, you know, perhaps been exposed to the importance of tracking stuff. And the second one is this large Transex project. So Greg O'Neill may be aware of it. There's a huge assisted migration project up the West Coast. So on the East Coast, Loic Orangeville and a bunch of collaborators within CFS have picked 10 sites, and they're growing out a huge number of trees, including comparing natural and improved sources where they can get them. They're going to be shipping seed to the Georgia Seed Lab, and then they're transferring it to the seed center with us. And we're going to keep all the paperwork. And again, using OECD just as a way of keeping track of the information. And yeah, I think as Dave pointed out, you know, I feel pretty fortunate to have had like really great mentors in this field. And you know, those of you that might know Ben Wang and George Edwards, and I think Dave is actually in this picture right here. But you know, most of the, there's very few people in this community in Canada that deals, especially on the seed center and seed testing side. So keeping the lights on, keeping everybody engaged. I really try to encourage a lot of young people to try and, you know, consider this, especially at nurseries. So I think just, you know, the more we get to do things like this, the greater I think it is. So
And yeah, just for anyone who is, out of country that you may not know, we do have a large research seed bank that's available for anyone in the world to request small samples of from us. So this is just, we've got 2 freezers. One is for conservation for high profile species, but this is most of our common species that you can go online and look at our seed lists and request it. So we do ship out hundreds of seed lots or hundreds of seed orders a year to various academic institutions and different groups, still doing provenance trials where necessary. So thank you.
It's break time.
Mm-hmm.
So we don't have a lot of time to integrate questions, so I hope you can go and speak to, because you're interested in really interactive people.
Mm-hmm. Oh, Brian's, Barb Thomas online says you didn't say the actual dates of the meeting for next summer.
Oh, it's July, week of July 10th, I believe, in that area.
Kalamaka Research Station. It's actually the first person I met when I came to BC at UBC, so a long-term friend. He's taken his time away from a family cycling trip to join us today, so thank you, Greg. And Greg.
Thank you very much, Dave. Yeah, and thank you for the invitation to be here. Dave, I really appreciate your introduction where you remarked on the importance of low tech, because this presentation is going to be decidedly low tech. So yeah, Dave asked if I would speak about, can everybody hear me at the back? Yeah, good. Okay. If I talk about climate-based seed transfer, and perhaps for an audience that would like to potentially build their own climate-based seed transfer. So we have a do-it-yourself climate-based seed transfer today. And my objective is to provide you with the tools to build your own climate-based seed transfer system. So I'll give just a couple of slides about a rationale for climate-based seed transfer. Most of the talk will be about the system and then a little bit of supporting research at the end. So I won't belabor this because I'm sure you've all seen slides like this. On the left, 3 examples of landscape level forest disturbance caused by biotic factors. We have, let's see, can I get that? Dothostroma needlecast, spruce beetle, mountain pine beetle. On the right, 3 abiotic factors, yellow cedar decline, drought mortality, and spruce and aspen dieback. So to the extent to which there is local adaptation for resistance or tolerance to any of these traits, then it may be possible to use seed transfer to limit some of the impact of these disturbances. On the right, we have Canada's current plant cold hardiness seed zone. So these are the zones that you see when you go to your horticulture shop to buy your azaleas, and they have a little number telling you, what, how cold they can go, to which zone, and they have a map on the wall. And so this system was updated a few years ago, and then the same algorithm that was used to produce this was used to generate a map of what it would have looked like 50 years ago had we used climates from 50 years ago. So, I mean, you don't need a lot of statistics to tell you that the plants that you can plant in, well, anywhere in Canada today differ a lot from the plants that you could have planted 50 years ago. So if you're a forester thinking about which species to use or which seed lots to use, this should really give you pause. All right, so let's look at how we might do this in forestry. This is my schematic of a cross section of a mountain, forested mountain, warm at the valley bottom, cold at the top. We have a seed source mid elevation. And what do we do in forestry? We constrain the distance that that seed from that tree or that seed source can be deployed in order to ensure that we're planting seed that's adapted to its local environment. But with climate change, climates are effectively moving uphill, as we just saw here. So climates are moving uphill because climates are getting warmer. So our constraints, our elevational constraints need to move uphill. And that's exactly what we did in 2000 and, well, this was published in 2008, but the policy change came about in 2009. I'll save you the 47 pages, up good, down bad. But climate's not just about moving seed up, it's also climates are moving, well, in the northern hemisphere, climates are moving north. And here we have our Douglas fir chasing after its home, its climatic home. So, no, I did not draw that. No, that is not my drawing. So if our climates, so in a jurisdiction with a topography as complicated as British Columbia is, in fact, for most jurisdictions around the world, it's not just a matter of moving, 2 degrees north, 3 degrees north. We have these complex topographies that, so climates are complex across the landscape. And so we need a more sophisticated system rather than just moving seed a couple degrees north. So when you have a complex problem, we turn to social media for our answers. So if you've used social media, you will have encountered the meme of being in one's happy place. So of course, one's happy place is on the beach or doing yoga or in a sunset, doing yoga on a beach in a sunset. So if people have a happy place, do trees have a happy place? And where is that happy place for trees? This is the kind of the central question when it comes to assisted migration. So I think the answer is right here. So I'm going to spend a few minutes on this graph because I think it's really, really important. This is the northern hemisphere temperature for the last 1,000 years. If you look at the thick black line, this is the smooth trend over 30 years for the last 1,000 years in the northern hemisphere, expressed as a deviation from the 30-year period centered on 1975. So climate has been relatively stable for the last 900 years until 1900, when the temperature spiked. So 50 years after the Industrial Revolution. And we have to advance a little bit because this slide is 21 years old. So I added a few years to make up for, to take us to present. So given that climate is moving about 1/10, the climate on the landscape is moving about 10 to 100 times faster than trees can keep pace, and trees can keep pace with climate change across the landscape. Given that, if you're planting a seed if you're planting a forest in Sydney, where the temperature is 10 degrees Celsius mean annual temperature, where would you get your seed? Would you get your seed from Sydney? Well, trees in Sydney evolved in a temperature that's about 1.5 degrees colder than the present climate in Sydney. So you'd want to go somewhere a little bit warmer. Maybe, I'm not sure what the temperature is in Seattle, but maybe Seattle. Because the trees there evolved, say, in 11.5 degrees. Or sorry, their current temperature is 11.5. They evolved in 10 degrees. So you go to Seattle, you get trees that evolved in 10 degrees, you plant them in Sydney. Great. Those trees, your forest is now perfectly adapted for today, but your forest needs to last for 60, 80, Northern British Columbia, 100 years. So we have to add a little bit, we have to go a little bit further south so that to warmer climates to account for the continued climate change. Now, this is not quite to scale, but our objective is to ensure that the plantation is adapted to at establishment and the plantation is adapted at harvest. And so to do that, our technical working group got together and decided that we would not split the difference. We wouldn't try to target a date between establishment and harvest. We'd err a little bit on the side of establishment because trees are most sensitive at establishment. So we said a quarter rotation, a quarter of the time it takes to get to harvest, which in British Columbia on the coast is about 15 years, in the interior about 20 years. Okay, so this distance here is about 2 degrees mean annual temperature. We calculate this migration distance for 7 different climate variables. And we use that as our guide to finding that happy place for trees. All right, so let's talk about now the system that we use, that we built in British Columbia and how we built it, and how the trees that actually get into the ground, how those seed lots get selected, those 300 million seedlings that get planted annually. So it starts with our biogeoclimatic ecosystem classification system, for which we have, this is our ecosystem system in BC. We have 17 zones. Each of those zones is divided into subzones and subzones into variants, for which we have, in our most recent rendition, we have 211 variants, Beck variants. You can think of them as climatically uniform polygons. And they may not be contiguous, they may be disjunct. So, and each of these is a small area that's relatively climatically uniform. And this is that same map now. Instead of latitude and longitude being your X and Y axis, we have mean annual temperature and log mean annual precipitation on the Y axis. We have the dry, cold interior and the wet, warm coast. And here we are right here in the warmest ecosystem variant. And in a few days in Vernon, in one of the driest ecosystems. So let's pretend that you are a seed owner. You have some seed from this variant right here. I'm not sure what it is, but sorry, I can't quite see. That's 5.5 degrees. And I think this is equates to about 1,000 millimeters precipitation. Where can you use it? Well, in a pre-climate change world, local is best. The closer you plant that seed to its origin, to its climatic origin, the better the productivity. And we call this the seed deployment space or the area of use. And okay, so now we want to know, well, how, so this is about building your own system. So how do you build, this is the first piece of information we need, is how to build, how big should this be? How wide and how tall should this oval be? So to answer that, conventionally, people would turn to provenance testing. And in BC, we're very fortunate to have the Illingworth lodgepole pine provenance trial with 140 populations tested at 60 locations, mostly range wide. And we take one of those test sites in central British Columbia, and we can plot the productivity at age 32. And we see that, and each dot represents a population tested at Carpet Lake, where the temperature is 2.2. So this population comes from a very cold location and it's growing in Carpet Lake. where the temperature is 2 degrees. So there's Carpet Lake, and clearly the further you get your seed, the less well it'll perform. So we can now look at the peak of the vertex of that transfer function, and we can drop down, because you don't want to restrict your forester to getting seed from exactly the cut block. You got to give the forester a little bit of leeway. So we come down to, say, 95%, and then you intersect that 95% horizontal line with the fitted curve, and this becomes the procurement area. This is where you can procure seed if you were planting at Carpet Lake or in a site with a climate similar to Carpet Lake. So this quantifies the width of that oval that we were just looking at. And again, we do this for multiple climate variables. Fortunately, most species, so here we have 5 different tree species. Most species have a curve, at least in Western North America, that is similarly shaped. So the steepness is somewhat similar. Now, Western white pine and cedar might be exceptions to that, but very generally speaking, these curves are somewhat similar. So that gives us a little bit of ease, I would say. In general, if you're trying to quantify the size of that oval, the temperature variables are should be about 2 degrees plus or minus. So you want to get your seed from 2 degrees warmer, 2 degrees colder, mean annual temperature, mean cold month temperature, and precipitation about 40%, whether it's summer precipitation, annual precipitation. Okay, now let's say you don't have provenance tests. Lots of jurisdictions don't. We don't have provenance tests for all of our species. Some of our provenance tests aren't as good as they ought to be. So, but we do have seed zones. So clearly, so these are the old geographic-based seed zones, and they've been around for 35 years, and they seem to have worked fairly well. Most jurisdictions have seed zones. So just because we're moving from a geographic-based system to a climate-based system doesn't mean we need to reinvent how far we can move seed. We know how far you can move seed. You've been doing it for 30 or 40 or 50 years. And if it's been working well, then you can take the distances that you've been allocating in your seed zone. So in this example, we've got the warmest and the driest. And we know the warmest and the coldest, and the driest and the wettest. So you can quantify that in your seed zones, and you can get an idea for what have we been using for the last 30 years. You may not have made it explicit, but if you have a GIS person, they can look at your zones and they can overlay a climate map, and they can figure out how far, what's been the maximum distance that we've moved seed within each of our seed zones. So you can derive these transfer distances indirectly from your existing seed zone maps. Okay, so we take the warmest, subtract the coldest, that becomes the safe seed transfer distance for temperature. You can take the wettest, subtract the driest, that becomes the safe seed transfer distance for precipitation. You can do this for, 3, 4, 5 climate variables. And there's this handy tool called Climate NA or Climate BC, or I believe then there's a version in Europe, Climate EU, that allows the user to very quickly find the climate for multiple climate variables just by pinpointing or by uploading and overlaying a grid of points. Okay, so back to our system. Here we have, we now know how far we can move seed from a precipitation perspective, from a temperature perspective. And now we go back to that picture we were looking at 5 minutes ago with the hockey stick and the migration distance. So this arrow here is, just go back here. Sorry, I should have put this in. This distance right here. This is the migration distance. Remember we were talking about how far we have to move seed to find its happy place. This is all just done with historical temperature records and looking at the temperature and the climate variables that we expect in 15 or 20 years. So it's fairly straightforward, that part. So back to our, okay, right here, where we go. So we have this seed lot. We don't want to deploy this seed lot locally anymore. We want to deploy it into a climate that's slightly colder than where it came from. So we simply migrate that oval. That's all we've done. It's just migrated that oval so that it's centered on this target climate. And that becomes the new target climate for our seed. And this is what it looks like using the seed lot selection tool that we built. The user selects, I have a seed lot or I have a cut block. Then they choose the species and the ecosystem where they plan. In this case, I have a seed lot, the ecosystem where that seed lot originated. And then the system returns where they can plant that seed lot and draws a map illustrating where that seed lot can be deployed. So this is with no assisted migration, and this is with assisted migration. So we've moved that seed into climates that are just slightly colder than where it originated. Now, from the perspective of a forester might have a cut block and they want to know where can they get seed. So it's the same process, but in reverse. Now we want to procure our seed from slightly warmer climates. We add this multi-dimensional climate vector to the climate origin of the climate of the cut block. We migrate our oval, and there's the seed procurement space with no assisted migration, the seed procurement space with assisted migration. So we're now procuring seed from slightly warmer climates. And since our system does not yet operate in the States, there's this awkward cutoff at 49. Hopefully we'll resolve that soon. Okay, Ontario, by the way, recently adopted a new, just last year, in fact, adopted a climate-based seed transfer system, very much like what I've been talking about. So in this example, here's a cut block. Where can I get seed? Well, you can get seed from all of these ecosystems that are slightly warmer than the cut block. And theirs actually goes into the States using postal codes. Sorry? Counties, thank you. Yep. And from the perspective of a seed user, here's that same ecosystem. Where can I use my seed? Well, you can use it in all these seed zones that are slightly colder than the seed lot origin. All right, how much time do I have left? Okay, I'll make it quick here. Okay, so British Columbia, cold and dry, warm and wet. Here's our ecosystems. And here's the cut block. Now I've got a square or a rectangle instead of an oval, but that's not too important. So today, here's where we go to get our seed for this cut block into areas that are just slightly warmer than the cut block itself. But every year, the climate keeps getting warmer, at least that's what we're anticipating. So this arrow gets longer every year. So this is what it looks like in 2040, so 20 years from now. So we're getting a little shy on eligible seed sources. So some of this might be resolved with our breeding programs, but there are areas where it may not be resolved with our breeding programs. So this I see as a sort of a looming issue for forest industry, not just in British Columbia, but in lots of jurisdictions where you're constrained by a southern border. So just to illustrate, this is the warmest and one of the driest coastal ecosystems. And this is where you can get seed with no assisted migration for this ecosystem currently. And this is current, but with assisted migration. 20 years into the future, the red area is getting smaller yet. And this is the procurement, that same procurement area, but illustrated into the States. So there's ample opportunity in the States, but we just need to figure out where for each of our ecosystems these areas lie. And the same logic applies. You know, we could do the same logic for Oregon. Where could it get its seed? The systems do not readily speak with each other. So our system doesn't speak with Washington, Oregon's doesn't speak with California, California doesn't speak with Mexico. So all of these jurisdictions have this looming technical challenge, which I think we need to start thinking about. And just one more illustration. This is ponderosa pine in the central interior. No assisted migration currently, with assisted migration, and then into the future. So this red area is getting a little thin. Fortunately, we've got a lodgepole pine breeding program in the works, but we need to start thinking about where we can get seed into the future, or at least the tree breeder will need to think about where she can find genetically adapted seed for the future. Okay, and I think that's it. I just want to thank all those folks who contributed, and there's many others who contributed to this type of work over the last few years. Thank you very much.
Thanks, Greg. Our next speaker is Sabina, the seed resource specialist with our Forest Improvement and Resource Management Plan. Before we head into there, besides Ontario and British Columbia, who else is dealing with climate-based seed transfer or assisted migration? Any other jurisdictions? You just raise your hand. Norway. Nobody else?
Awesome. Thank you everyone for joining us today. So I'll be doing a quick overview here of the seed planning tools that folks can use in BC. So I'll start off with our first tool here, and that is the Seed Planning and Registry, also known as SPAR. SPAR is a web-based information management system that allows access to the Provincial Registry of Forestry Seed, a comprehensive seedling request system for meeting annual reforestation needs, and seed planning tools, which includes reports, data extracts, and mapping tools. So the application allows users to register natural stand and orchard seed lots that follow the Chief Forester standards. Users can manage their inventories, meaning that they can move seed into surplus and sell it to others, or keep it in reserve status for their own reforestation needs. Users can also run queries for seed planning and inventory management purposes. So here we can see the output for a suitable seed lot search for PLI seed to be planted in the SBS MC2. Seed lots with the highest genetic worth appear at the top to make it easier for users to find seed lots that fit the 5% or better genetic worth guidance as outlined in the Chief Forester standards. This is what Brian was talking about earlier. So outlined in blue here, we can see the reserve and surplus balance of each seed lot. Additionally, in the orange outlined area, we can see buttons for quick links to the seed lot detail screen and the CBST screen. So there is a lot of data in SPAR, and when I'm working with clients, I find that sometimes they can find the amount of information overwhelming. However, it's made available so that folks using SPAR can be empowered to select the seed lot that best fits their planting site and achieves their management objectives. Okay, so let's take a look where those two, like the DT and the CVST button, take us. We'll take a look at some of the information that they provide us with. So hopefully you can read all that pretty clearly. So the DT button, of course, takes us to the seed lot detail screen. This screen contains information on the genetic class and worth, the collection year, the seed source, quantity, and test information, and also collection information. So you can see, whoops, you can see all these different sections right here. So in this example, we can see that this is an interior lodgepole pine seed lot. It's B class. It's collected in 2020. It's collected from the IDF DK4 or DK3 right here. We've got the elevation min, median, or min, mean, and max, the lat and long of the collection site. Here we have, at quick glance, a bunch of information on the quantity and test information, as well as some of the extraction information right here. So what's nice about this screen is that it has a whole bunch of tabs that folks can go to get more information on this screen or on the seed lot here. So what I've done here is I've gone to the test tab, and we can see that there's really a vast amount of test information here. The test screen here is showing the test results that are performed at the Tree Seed Center. In this example here for an interior hybrid spruce seed lot, we can find the germination testing that has occurred, as well as the results of the fungal assay testing. So you can see here the historical germination testing that's been done. And this is the Spirococcus test result here. One thing that I'd like people to sort of appreciate from this slide is just the amount of work and time that goes in to the quality assurance at the Tree Seed Center. So this is a lot of really great work and a lot of really good information here for people. So this kind of information is useful for users selecting seed lots and for nurseries planning out their, their growing plan in greenhouses. Perfect. Okay, so here I've decided to include a screenshot of the seedling request screen. You can see there's quite a few fields here. So this screen collects a lot of data and a lot of information. This is done so that when folks go to the lot selection screen right here, they're selecting a good seed lot for their planting site. So we can see here that this person is looking for an interior Douglas fir seed lot. They're planting in the IDF DK4. They're looking to plant 400,000 seedlings, and you can see their stock type information right here. This is a 1-year-old 412B that they're looking to plant in spring 2023. So once they've entered all that information, they're taken to the screen, and the seed lot selection screen only shows seed lots that are climatically suitable to their planting site. So you can see this individual has gone in and selected seed lot 451 or 45012. And then at the bottom here, the selected lot information is shown down below. And what we can see here is that at the top, they're requesting 400,000 seedlings. But at the bottom, what this is showing is the calculated amount that's the amount of seed to grow 329 seedlings, or 329,000 seedlings. And so there's a bit of a drop here between these two numbers. And so the reason for this is gram reductions. So on sort of, the theme of seed supply, one of the mechanisms that we're using to ensure that we've got a good seed supply is encouraging nurseries to do gram reductions. And so this can be done by the nursery, the licensee, or it's specified in ministry sowing contracts. So here I've just got a quick video of the nursery gram adjustment screen. It's really quick and easy to go into. People can pull up the seedling request and just go ahead and reduce the number of grams. And this is the nursery gram adjustment screen here. Okay, so let's quantify some of the seed savings. So this is the last 5 years of reductions by sowing year. This is for all species. So over the last 5 years, there's been nearly 200 million seedlings worth of seed that has been saved. This equals to an average of 40 million per sowing year. So this is fantastic. This is a trend that we want to see keep going. Okay, so seed saving continued. Another mechanism in saving seed is ensuring that folks are selecting the appropriate seed lot to meet management objectives. So in SPAR, we have numerous seed lots which have pest resistant values. And so when someone is using a seed lot that has, say, a terminal spruce weevil resistance, and they're planting it in an area where there is no terminal spruce weevil, then in a sense, that's a bit of a waste. We want to be planting these seed lots where they're really, really needed. And so this is a tool that foresters can use. It's a pest hazard map. This is created by one of the ecologists, Will McKenzie. And so folks can see here the pest hazard rating for, I believe this is terminal spruce weevil, but you can see high risk areas in red, moderate in yellow, and low risk areas in green. So yeah, so by using the resistant seed lots where you really need them ensures that there's going to be enough to go around to everyone that needs it. Okay, so Greg touched upon the seed lot selection tool. I'm just going to go into a little bit more detail here, I think. So there's two main features in this tool here. And so there's ways that people can take a look at the procurement area of a seed lot and the deployment area of a seed lot. So in this instance, I've used the I have a top block feature in the tool to find climatically suitable seed lots. In the top table, you can see the procurement spec that you would like to plant FDI, if you'd like to plant FDI into the IDFDK3. So that's the search parameters that I put in there. In the table is a list of seed lots that fit into that spec zone. So you can see here, this is sort of the seed transfer matrix right here, and this is the seed lots that fit that seed transfer matrix. And so if you also wanted to go out and collect a seed lot, these are your procurement areas. So now we'll go to the other feature of the tool, which is the I have a seed lot function. And so in this example, I've entered orchard 352 and clicked the representative seed lot. And here we can see the deployment space for orchard 352. So this is a nice way that orchardists can take a look to see exactly where in the province their seed can go. So we'll see here, there's the average climate space right here. The seed spec of the orchard is SBS DW3. And it can be planted in the highlighted spec variants right there. So Brian touched on this a little bit. This is the forecasting seed need project. So an important piece in understanding challenges in seed need is understanding future seed needs. So the Forest Genetics Council led a collaborative project in which a consultant worked to solicit feedback from experts, both forecasted harvest rates and on silviculture practices. So in the diagram on the right, you can see various input sources that were used to forecast seed need. Broadly, these were harvest input sources, and regeneration input sources. So here we have the output of those results. We can see the species of interest right here, and we can see the annual number planted for each of these time frames right here. So 46,000 seedlings planted annually between 2020 and 2024. And so this data was then loaded into the seed planning dashboards here. And so what I have here is a screenshot of the seed orchard dashboard. And this dashboard includes data on each orchard, including its deployment area, actual and forecast production, seedling conversion factors, and number of parents, genetic traits, and as well contact information right here. So on the bottom left-hand corner, we can see the orchard supply versus planting demand widget. The red line is the forecasted seed production for all FDI orchards. The gray bars are historical seedlings planted, and the blue line represents future seed needs right here. So there's also a mapping feature just in the sort of top section here. This can be used by both orchard managers and foresters to view the deployment space of seedlots and orchards. So if I'm a forester working in a particular area of BC, I can use this mapping tool to sort of see what orchards service my area, and then I can think about approaching those orchards and securing seed sales. Okay, so our next screenshot here is the seed supply and demand dashboard for coastal Douglas fir. In the top graph, we can see the historical planting from results. So this is your results data right here. And to the right, we have forecast seedling needs to 2040 by species and Beck variant. So right here. So the bottom graph contains the historical and forecast seed need orchard productions for the same species and Beck variant selected. So you can see this is the data here, and that's your forecasted seed need, and this is your production. So the line on the bottom left of the graph, of course, reflects historical forecast production compared to actuals. The line on the bottom right reflects the total forecast seedling demand from the graph above to compare with future orchard productions. So a quick summary of what we've reviewed. We've looked at the uses and the data available in SPAR, and that was just a sort of quick venture into SPAR. There's many more features in that application. We've talked about seed saving in SPAR. We took a look at the seed lot selection tools, as well as the seed orchard dashboard, the seed supply and demand dashboard as well. So that was my quick overview of all the seed planning tools that folks can use in British Columbia. Do we have any questions?
Later. A few points that I would like to make. Sabina did mention results, and SPAR is a system we use for managing seed, but in terms of our chief forester standards, the companies are judged what actually goes onto the landscape, and that's where our result system comes in. That's where we report actually what gets planted. One thing I'd like Greg, maybe, or Sabina to talk about, because we still have people from other jurisdictions dealing with seed orchards, is how we determine the seed lot variant. How do you assign an ecological zone or a variant to a seed orchard seed lot or seed orchard?
For sure. So in orchard, and I would definitely like to see that each orchard we have parenting, and we know that those parenting is from all the tests and how it goes on to, and so that feedback, that orchard being nice, that feedback that I was talking about earlier, what that is the mean time change of those parents, and then the time change of the parenting, and essentially I guess a weighted average, and so that is then linked to a vectoring and yeah.
Greg, do you want to comment on possible controversies maybe and other opinions on how that system should work? And that might invoke some discussion among people.
Sure. So we've got wild stand seed, and we know the ecosystem where it came from, so that's obvious. When it comes to orchard seed, you've got multiple parents. Sometimes they come from multiple ecosystems. So as Sabina said, we take the weighted climate mean of all the parents, and we find the nearest ecosystem. That's the way we've been doing it for 5 years. Alternatively, we could also take the climate mean of the test sites where it was tested and find the nearest ecosystem. Fortunately, the testing environments are often very similar to where the parents came from. So which system we use often doesn't really matter. The advantage of using the test site climate environment is that it ties the genetic worth more accurately to the climate of the ecosystem. So the genetic worths that we're assigning to those seed, to the orchard seed, they're more appropriate for those ecosystems where they're being deployed. So that's the main advantage. Also, it's permanent. Like you don't your orchard gets tested in a certain environment, and it doesn't change every few years as the composition of the orchard changes with roving and infusion of new clones into your orchard. It's a bit more stable.
Yeah, so a lot of concepts, maybe a little overwhelming. You know, it took 10 years approximately for CBST to come into practice. So it is something that doesn't just happen overnight.
David, could I just ask you to explain to those of us who live in Europe and aren't used to traveling vast distances you are over here, geographically, north, south, what latitudes are you dealing with, and what proportion of your climate over here is maritime and continental?
I'm going to just give that to Greg.
Southern BC, the limit is 49, except for the very tip of Vancouver Island. The north is 60, so 49 to 60, and about a quarter of the province is what we would call coastal or maritime climate.
Okay, thanks.
Way better answer than I could give.
Tomorrow, Dave, we're going to have an ecologist that's going to describe the different zones in British Columbia. That'll give you a much clearer picture.
Because it's very different from what we see in the Northwest Atlantic Seaboard, because we're pure maritime right where we.
And our programs are very much divided between a coastal and interior program, you know, totally separate programs, even for the same species. All right, I'm back. I'm going to try to make up some time. I did want to touch on, since it was one of my indicated bottlenecks in terms of reproductive biology, and sort of emphasize why it is important. I'm not going to go through all the details of my slides. I have another quote. You have a maximum of 1 beer supplied by me if you even get both quotes. But and we are stalled.
Nabil.
Is that who guessed?
Yeah, Nabil guessed it.
Anyway, the quote's related to, I just really wanted to, we get into the technical aspects of seeds. So let's really start at the beginning. You know, where did plants originate? And, you know, it really is about 450 million years ago that first land plants appeared from the oceans. And I think what we don't really appreciate is that these mycorrhizal associations occurred at about the same time. It isn't some new evolutionary association. These are really ancient associations, and I think they are important. And when we're dealing with early land plants, they really just reproduced like ferns, and the spores really required moisture in those humid environments. Even before seeds, we had the evolution of xylem that allowed plants to move into more extreme environments in association with those mycorrhizae as well. Another thing, as we move through seed evolution, we have a very simple system where we had one spore type. Then we moved into heterospory, where we had separate male and female spores. The evolution of an integument and protective systems around the seed. And then we developed some pollen reception mechanisms, which really separated out the need water to encourage fertilization. So why seeds? I think many people here, seeds are kind of their life. So you know, it's to the converted here I'm talking to, but I really look at it as it's amazing structure. It's really concentrated life. You have an embryo there that's going to give rise to your future plant, and you've got this sequoia tree that's originated from that small little seed. It's quite amazing, and it's an amazing package. You have the food, the nutrition, and you've got protection from the outside environment, from desiccation, from direct feeding. As we moved along in terms of plant evolution, we evolved different dormancy mechanisms to avoid unfavorable conditions. Most of our conifers, we're talking about cold or north temperate species, but looking around the world, there's many different triggers that bring plants out of dormancy. In association with the fruiting bodies, we have amazing dispersal packages that are wind related or mammal related. It's quite amazing. We are dealing mainly with gymnosperms in British Columbia, and in the big scheme of things, they're really the vast minority of plants. They're not any less important because they are very important worldwide for timber production and other purposes. But in terms of the number of angiosperms, they really are quite pale in comparison. These two groups diverged about 310 million years ago, and I'm sure most of you are familiar with the differences: presence of the ovary structure in the angiosperms, and what we call the naked seeds in gymnosperms, and differences in the nutritive tissue. Dinosaurs of the plant kingdom, that's really what the conifers are. And we can see, never mind Jurassic Park, conifers were around long before that. So it is quite amazing. Another view, and they've survived some of the big mass extinctions on the planet. I will just draw your attention because something very particular with conifers, this ovule inversion that I'll have a slide on, happened very early during the Permian period. A lot of our history to do with conifers or plants in general is related to continent separation. This supercontinent dividing into the northern and southern continents about 200 million years ago. And basically we got the podocarps and Ericaceae moving to the south, predominant families in those areas. And Pinaceae being the primary family in the north. Two main genera that make up in the north, it's Pinus, about 109 out of those 627 species. Quite different, monoecious, so one house, male and females on the same tree, whereas the podocarps, the other large group in the south, decided to go a different route. So you do have dioecious species with male and female structures on different plants. Just some of the features here I'd like to talk about in terms of our BC genera, and most of us are falling into Pinaceae and Cupressaceae. In terms of the bract scale complex in the cones, they're easily identified, or they're fused in the Cupressaceae. Seed wings are formed in the ovuliferous scale in the Pinaceae, where they're really from the ovule and the integument, and that's really a close connection. And for us, that's why we don't de-wing cedar, because we are going to do some damage to the seed itself by removing the wings. Two things I find quite fascinating, across these widely divergent families, we have some characteristics that have co-evolved quite separately: resin vesicles in these species and serotiny. And I'm just fascinated by that, how those things have evolved quite separately. Cone structures that house, ovules, seed cones being very basically modified shoots, and pollen cones, and a lot of diversification among the seed structures, where pollen cones have been quite simple and remained having very little diversification. Ovule aversion, this is quite an interesting thing, and you might think, well, why aren't you pointing your ovule out to these wind pollinated structures, and doesn't that make sense? But no, the ovule actually points into the cone axis itself, and it may be upright, it might be pointing downwards. And it's really allowed for the evolution of the wing structure. It probably brings the seed in closer closer vascular connection to the axis of the cones. But it's kind of unusual and not what you'd actually predict to be the case. I like this map just in terms of some of the general relationships and how it feeds into some of the things we do with conifers and seed processing. Whereas for most of us, you know, Pinus and Picea, these are wet de-winged species. There's a very weak wing connection between the seed and the wing. This may tie in with the, you know, very standard sort of pollination drop mechanisms with micropylar arms, certain type of pollen. Down here, we have all of these genera producing resin vesicles, which we really don't understand the purpose of. You know, our big concern is, you know, we damage them during processing, we're going to decrease the germination of that species. So we are very conscious of them, but why are they there? I think there's a very poor understanding of that. In the middle, we have what interests me a lot is, and I'll show another slide next in terms of both Larix and Pseudotsuga. These are species that tend to have more seed pathology issues than other species, and this may be tied to their pollination mechanism more than anything else. And I talk about, you know, conifer pollination, the three things that are really important: the orientation of the ovule, the pollen type, whether they are saccate with bladders or not, and the secretion mechanism, whether it's a pollination drop that's exuded, whether there's a delayed secretion or none at all. And I think there's been quite a bit of research, some at University of Victoria, where these pollination drops are really fluids that sanitize anything that falls through, you know, any fungi, any bacterial that'll come through, they're basically being cleaned. And that's one of the big functions of the pollination drops. And my last slide is just my plug for, again, sort of the reproductive biology end and how it, you know, feeds into our seed orchards. And sometimes, you know, I think we all know about apices and where cones come from, you know, and the influence of tree vigor. But, you know, what are we learning about reproductive biology to increase cone production? You know, do we really know it all? And based on the amount of work that's being done today, I think people assume that we do. And I'm not really convinced, especially in terms of the impacts of climate change. So everything else seems fair game to study, but, you know, I just come back to this, my theme, and I'm one of the organizers, so I get to pound one of my themes. And that's it, that we really don't have enough work in this area, especially with the amount of money that we invest in seed orchards and the expectations from them. That's it. Our next speaker is Dr. Michael Stoehr. Michael's a graduate from Lakehead, and he has a history working on tree seed science. Then he did his PhD at University of Toronto and some postdocs at UVic. He was most recently our host of Douglas fir breeding, recently retired, and he worked in seed production research and very graciously came out of retirement to help me with this morning because it was very difficult to find someone to speak on this topic. I would have chosen Dr. Patrick Van Atticus at University of Victoria, but he's actually in England right now welcoming his first grandchild.
So I'm your second choice.
You were kind of a little bit further down the list.
Okay, thank you very much, David. When David asked me to give this presentation, I hesitated at first because I haven't been involved in seed production research in at least 15 or 20 years. But then I thought this is too important of a topic that, you know, research needs to be done in seed production, and David just pointed it out as well. So I really feel strongly about having a functioning chain of supply, starting with the seed to go to seedling production in the nursery, to go to reforestation in the operational fields. So talking about low level or low technology in the slides, I mean, Greg mentioned that you ain't seen nothing yet, because as you can see, I'm retired, so I don't have the huge ministry machinery behind me that makes nice slides. So oh, that's too complicated. Okay, in BC and probably many other provinces across Canada, we are operating on public lands. And the seed that we produce must meet certain standards and criteria. I'm going to talk about the genetic diversity standards and the genetic gain standards that our seed lots need to have in order to be deployed on public land. I'm not going to talk about adaptability and resilience against insects and diseases, because that is taken care of during the selection and breeding process of the breeders. So they take care of that. NE is our parameter to estimate genetic diversity. And here I'm showing you two scenarios of a totally hypothetical 4-clone seed orchard. On the left-hand side, the gamete contribution is fairly even. On the right-hand side, the gamete contribution is fairly skewed. So P is the actual proportion of the contribution of the gametes, that is both male and female gametes, i.e. the seed cones and the pollen. And as you can see, it's fairly even, 30%, 20% by the 4 clones. You sum that up, you square these values, and then you take the inverse of the sum, and this is then your NE, the effective population size. On the right-hand side, it's much more skewed. So going through the same simple math, this clone produced most of the seed or most of the gametes. This clone didn't produce any, and therefore our NE is much, much lower. So I was thinking of using this term seed orchard efficiency, which is the NE divided by NC, and NC is the census number or the number of clones in the orchard. So this scenario number 1 gives us a seed orchard efficiency of 95%, number 2 only 45%. So to me, clearly this seed orchard is functioning a lot better than the second one. Now, we have options and methods to balance out the gamete contribution of our individual clones. We can do cone inductions using phytohormones, but that is fairly tricky, because if you apply too much phytohormones, your tree will die. Timing is of the essence, and a lot of research has been done in this particular field, but I feel strongly that we still need to do more. We can also combine individual crops per clone in individual years, and then sort of customize our seed lots. Now, this requires clonal collections of our cones, and also clonal processing by the seed center. And I know seed center is extremely busy, and they really cannot afford this extra piece of work to treat individual, let's say from a coastal Douglas fir seed orchard, rather than having 1 or 2 seed lots coming in from that orchard, having 30 or 40 different seed lots coming in. So it's a huge increase in effort. We can also use supplemental mass pollination, but that is also very labor intensive. We need to collect the pollen, we need to process it, we need to store it, and then we need to reapply it. At the end, we really don't know whether it was successful or not. We can also use another trick that was promoted by Dag Lindgren out of Sweden, the unequal clonal representation, where the high gain clones are in the seed orchard a little bit more frequently, and the low gain clones are in much lower frequency. The other thing that we need to do is avoid relatedness in our seed orchard selections, because relatedness inadvertently leads to a reduction in genetic diversity, therefore a reduction in NE. By the way, in BC, we have a minimum standard of NE equals 10. That represents about 95% of the genetic diversity that you find from where our parents in the seed orchards were selected from. So 10 is a relatively low number, but because of the mating dynamics of conifers, it represents 95%. Now, I think that the reason why research in seed production is not as common anymore is I think we may be the success. We may be the victim of our own success, because we are producing extremely good and large cone crops out of our seed orchards. But a good seed crop does not necessarily mean that all of the assumptions are met. For example, are our gamete estimates reliable and accurate? And I'll get to that point a little bit more later. Is random mating happening? Or how are the mating dynamics affected by the phenology in flowering? Because we know there's some clones that flower early, they only can have sex with each other, only 2 or 3 clones. Then the bulk of the seed orchard flowers at the same time. And there's good mixture of pollen and the mating dynamics are fairly good. On the right-hand side of our distribution, they're the late clones. Are the late and the early clones more susceptible to pollen contamination? We don't know. The other thing is, only because we collect seed from each individual clone, does that mean that their germination behavior is such that they represent the clonal proportion in our seed orchard? We don't know that. Yusri Al-Kasabi did some really good early work on these kinds of questions, but we have moved on. He has done the work on early selections. We are now in the 3rd or 4th generation of selections. Our trees may be behaving totally different. Simple cone analysis can be done. Pedigree analysis using molecular tools, and I'll again mention that a little bit later, is definitely the way to go. It's complicated, and I don't know the nitty-gritty details about it, but it is definitely the future. And then, needless to say, germination tests are very important as well to determine whether there's genetic or family variation in germination parameters. Now, the second topic is the genetic quality of our seed. And I'm referring to the genetic worth or the genetic gain of a seedlot that is being produced in a seed orchard. In BC, we call it GW, which stands for genetic worth. And if a seed orchard or a seed lot produces a seed that has a GW of 30, that means at rotation age, we are expecting 30% more volume gain using that seed orchard. So it's fairly high gain. Not all of our seed lots coming from orchards are that high. It ranges from 10 to 30. But the higher the quality of our seed orchard is, the more impact pollen contamination will have. Let's say in a genetic gain orchard of 10%, at 50% pollen contamination, the genetic gain drops down to 7.5%. In a seed orchard that has 30% gain, again with 50% pollen contamination, the genetic worth drops down to 22.5. It's always a quarter. So a quarter of 10 is obviously less than a quarter of 30. Not only do we reduce the genetic quality of our seed with pollen contamination, but also it reduces the adaptability of our seedlings, especially if the seed orchard is far removed from the deployment area of our seed. And it's very similar to what Greg mentioned, the impact of the surrounding trees on seed quality is much more important and much more drastic in high gain orchards. The bottom line is pollen contamination will affect our expected levels of volume that we can produce and allowable cut allocations. Pollen contamination, unfortunately, is very difficult to estimate because it happens in nature. We really don't know what's going on. Right now in BC, we are using quite a bit of pollen monitoring, but that has its own problems. I feel the only reliable way is using molecular tools, specifically SNP chip technology. And I was talking to some SNP chip experts, and they said we could, in theory, have one SNP chip that covers all the conifers across Canada, and it's a relatively small and relatively cheap thing to produce and develop. But more work needs to be done, and again, there's some area of research that would be very fruitful. I'm not saying that we need to evaluate each seed crop using this SNP chip technology, but we have to do spot checks because our assumptions, we may not know whether our assumptions are met, and we are operating on public land. We owe it to the public, especially here in Canada, where most of it is done on public land, that we use the best input variables for any kind of modeling that's being used for allowable cut calculations. We need to verify our assumptions. For example, in a seed orchard, when you determine the gamete contribution for each female, we are taking the cone volume. We harvested the cone by clone. We harvest the cones by individual clones. We determine how much volume in cone volume there is, and that is a surrogate estimate for the female gamete contribution for each clone. But we don't know whether those cones are full of seed, whether there's only half the seed in there, whether they are non-viable. So there is definitely room for verifying our assumptions. The other thing is male gamete determination is based on surveys. People in the seed orchard walk around and look at individual trees or individual ramets of individual clones, and they say, okay, this is a scale of 1 to 10, maybe this is a 10, this tree has only a 5. So again, we don't know whether, only because a tree produces a lot of pollen cones, is it very successful in siring seed? We don't know that. So there's definitely room to check our assumptions because it is vital and we owe it to the public. I also think that we need to prepare. We may encounter unforeseen seed problems, and we need to have these research scientists on standby in case we need to get to them in a hurry and say, okay, we have a problem, the seed are not being produced, seed is not viable, all kinds of different aspects. For example, in lodgepole pine here, our seed production is falling way behind what we expect. So our approach is just make the seed orchards much bigger, and you just cope with the lack of seed production by individual trees by having 10 times more trees than you would actually need. And what people don't realize is that many of our seed orchards are perfect for doing research and experiments in, because they are single trees and they are randomly arranged on the land. So it's a perfect experimental setup. So if we could stimulate our or show our interest and come to these seed researchers that may or may not exist, saying that you can access our seed orchards, and it's an ideal situation. As I mentioned earlier, IUFRO's work was done on early selections. Now we have trees that have genetic gain up to 30%. Is their seed production behavior different from the early selections? We don't know. Using forward selections in our seed orchard, which means you're taking the best tree from the best family. Now, the second best tree in your test is probably coming from the same family, because that's how genetics work. Good families produce good seedlings. So there is very much, there's a really good chance that you are selecting related individuals coming from the same family. Now, how is the mating affected by having trees that are full sibs to each other? We know that trees don't like to self. There are mechanisms that prevent selfing, or mechanisms that prevent a self seed from being established. But we really don't know about mating among relatives. Except for cedar, they can self. They were fine with that. Yeah. So again, using pedigree analysis and a SNP chip will definitely will give us some good insights on how our seed crops are, how good they are. Pollen contamination needs to be. We need to detect the amount of pollen contamination. And I was happy to see that somebody in the back on the poster said, "Oh yeah, we need to work on pollen contamination." So a SNP chip and the prevention. I was at a meeting a few years ago, and the Swedes showed some examples of these breeding halls where they have big greenhouse. The trees of the seed orchard trees are in the greenhouse, and they were blowing. With some big propellers, they're blowing the air through and prevented pollen contamination from the outside. As I said, it's very important that we have sound seed, because we need to have a full chain of supply from seed to seedlings in the field. I think that's it.
You might as well come back to work.
Oh yeah.
At the University of British Columbia, formerly a
let's do it. This doesn't collect anything.
Postdoc at the University of Oxford, and previous to that, and her PhD from the University of Georgia. One comment though, Michael and Greg are just scheduled to be here for lunch. If both of you reconsider, you can get on the bus with us. But otherwise, if you do have questions for Michael or Greg directly, please catch them at lunch.
Yeah. Okay, great. Yeah, thank you so much for letting me speak here today. As Dave said, I am a postdoc in Sally Aiken's lab, so I'm kind of standing in for Sally today. And that's at the University of British Columbia, which is on the traditional and unceded territory of the Musqueam people. Today, I'm going to talk to you about genetic population assignment and its potential for seed provenance ID. I've actually been doing some work on the NE stuff. That's not what Dave asked me to talk about today. So if you want to chat with me about that later, feel free to. And I want to start off by saying that if genetics makes your eyes glaze over, I'm sorry. I think some geneticists in the past made genetics seem confusing to validate their job. Genetics is straightforward. It can be easy to explain. I'm giving you a brief overview. So if you don't feel that way, don't take it off of this. It is can be applied for sure. And so what is population assignment? This is where you have an individual of interest. I have a tree here, it could be a seed, and you want to know what population it came from and therefore where in the landscape it came from. So in trees, this would be the same thing as provenance identification, and it is highly dependent on whether your populations are sufficiently differentiated at a fine geographic scale, which I will get into. And it's based on characteristics and probability. And so it's based on the characteristics of your individual of interest and your populations that you're trying to assign it to, and the similarities between that individual and your populations, and based on if those populations are actually different. So you can calculate a probability that your individual came from each of those populations. And then if they're geographically referenced, understand where it came from on the landscape. And population assignment has a lot of different applications.
It's used a lot in illegal harvest, though caveat here, illegal harvest is usually done at the species level. And so this is when you have a wood sample and you want to know if it came from a critically endangered species. Population assignment is intraspecific, so we're looking within a species. And so a good example of this was a study done in Brazil where they have these endangered palm species that are used in ornamental landscaping. And so they ran a genetic analysis to understand what natural populations those planted palms came from to help with conservation and management, which is another application of population assignment. So it's used a lot in fisheries in order to identify a hatchery individual versus those from natural populations. And it could be used in seed provenance ID, although this is has fewer applications, though. If I don't cover one, you're like, oh yes, this is so used, please point it out. But a good example is with Douglas fir grown in Europe. They ran a study to try to ID the provenance that it came from in its native range. So how do we do population assignment? Well, we need samples that are referenced, spatially referenced genotypes of samples from all possible populations, and we need to have population structure in those genotypes. And so if we're talking about genotypes, the first step is to develop genetic markers. And so here our characteristics are going to be genotypes or allele frequencies. And the goal is to have markers that are highly variable in order to pick up those fine scale differences between our populations, or they may have low variability but be geographically restricted. And in population assignment, we're usually talking about two different types of markers. And so those that we're probably more familiar hearing about are nuclear markers, which means that they're targeting our DNA or our genome. And our genome has coding regions, which are regions that, or genes, which is what we usually refer to them as, that are coding for proteins that end up in a phenotype. And we also have non-coding regions that we're not really sure what they do. Sometimes I use trash cans, which I was told definitely don't do that because they're not garbage. I use question marks. I've used teenagers because we don't understand them. But I also want to point out this is an incredibly simplistic view. If only it were one gene for one phenotype, we know that it's actually hundreds to thousands of genes that are contributing to these phenotypes. And so when we're talking about nuclear markers, two of the popular ones are microsatellites, which are becoming more old school, and they're targeting these non-coding regions. And then we have the new kid on the block, although he's not so new anymore, single nucleotide polymorphisms, or SNPs. And so since SNPs are more popular, let's kind of break this down. So what we're doing is targeting different locations or regions of the genome. We call these loci, and we're looking at sequences. And so single nucleotide polymorphism, that's why we call them SNPs, it's a mouthful, means that they differ literally at a single nucleotide. So our nucleotides are A, C, T, G. And so if you look at that first region, that first locus there, our individuals are differing at A and C. And the second one, they're differing by T and G. And so when we look across many SNPs, we're gathering these characteristics in order to look at similarities and differences among our samples. And these nuclear markers are inherited from both parents. So we have two alleles, C and T, or A and A. They are species specific, which means that we have to develop these markers for every single species that we're looking at. And when we're talking about microsatellites, that usually means that we're looking at 15 to 20. When we're talking about SNPs, we're looking at hundreds to thousands. And they are highly variable, and in the case of SNPs, spread throughout the genome. Now, the other popular marker type are organellular markers. So this is circular DNA that is coming from either mitochondria or chloroplast, and we're targeting a sequence, just one region in that DNA. We only have one allele because it's only coming from one parent. So in the case of conifers, mitochondria come from moms and chloroplasts come from dads. And this usually means that they also have lower variability, but especially in the case of mitochondria, if they're maternal, they're normally more geographically restricted since seeds fall closer to their parents, or their mom anyway, maybe not their dad. And so then we're going to be assessing population structure, which means that we need to genotype all possible populations that our sample could be coming from. And we're talking about these trees that have a great geographic distribution. This could mean a lot of investment. And when we're talking about assessing population structure, figures that you are probably accustomed to seeing, or would be if this is of interest, is the structure admix plot on top, and then the geographic mapping of those results. And so in an admix or structure plot, each bar or line represents one individual. And if they're all the same color, that means they're coming from the same genetic group or cluster, which roughly correlates to a population. And if you have individuals that have multiple colors, that means that this is an area of mixing between two populations. And so they have genetics from both populations. And then we can just put this on a map so we understand what's going on geographically, which is usually more helpful than a bar plot. And a more recent way of looking at this is using a principal component analysis. So here, every point represents an individual. We're plotting them on the first two principal components, which just means that if they're closer together, they're more genetically similar. And so we can start to pick out populations in that way. And then the final step is to assign your sample. And so now our similarities are going to be genotypes or allele frequencies. You're going to calculate a probability that your sample came from that population, as well as calculating a % error. And then if your populations, we know where they came from in the landscape, you can determine where your individual came from on the landscape, as well as have some idea of how confident you are that your individual came from that area. So can we do population assignment in BC conifers? I'm focusing on BC because we're in BC and I'm in BC, but this could really be applied to a lot of tree species in general. And so it really depends on the scale of geographic interest. So how close, how specific are you trying to get on the landscape, as well as the life history of the species. And so when we're talking about scale, we can probably get to the continent scale. Probably know it came from North America versus say Europe. You can probably get to the country scale. You can probably know that it came from Canada versus the United States. And in most species, you might even be able to tell that it came from BC versus Alberta. But once we get into BC, it becomes really difficult to get down to that resolution of where it came from. And this is down to conifer life history. Conifers have this great wind dispersed pollen, which means that our genes go a very long distance. And so we have this great admixing between our species. And so all of our populations end up being quite genetically similar, which means that the probability that your sample came from any one of those populations is quite high. And so your error or your error is quite high as well. And so your confidence in that population assignment is quite low. And a great example of this is lodgepole pine. So here's one of those PCAs that I talked about, where we had done Ian McLaughlin had done a SNP analysis across samples from breeding zones in Alberta and BC, and you can see that there's really no population structure there. And another study was done on big leaf maple, which is the map that I used earlier. So bonus points if you picked out that was that species. And you can see in the PCA to the right that the green and the purple clusters are in California, and so we see structure there. But this big, huge glob is all of the Pacific Northwest. And so they found that there's a 50% classification error, which meant that if you're trying to assign your sample, you're wrong about 50% of the time. It's not ideal. So can we do this in BC conifers? Again, it depends. So there's some characteristics of species that might make this easier at different scales. So one example is if you have different varieties, you could, for example, determine if it came from the coast or the interior. And that's the case with Douglas fir, which was shown in the Co-Adapt Year project led by Sally, and this bit was led by Rafael Candido Ribeiro and Brandon Lind. And they found that when they did a PCA on sites, they could found the structuring out of the coastal sites in green and the interior sites in purple. And this is again shown on a map. So you're getting some finer scale resolution. And this was similar to what was found in that Douglas fir study I pointed out earlier, where they're looking at Europe. They had the highest confidence when they're assigning to variety versus when you get down to population level. If there's hybridization, you may also get greater geographic resolution. And this can be shown in interior spruce here in BC. So interior spruce is this cool hybrid complex between Engelmann, white, and occasionally Sitka spruce. But here we're showing the percent ancestry of Engelmann in red and white spruce in blue. And so you can see that we're really getting the structure across BC and Alberta. And to put proof to concept, a project that Sally had done actually was able to use this percent ancestry to pick out samples that have been mislabeled, which is really helpful. If you have small remnant populations, specifically in a species of conservation concern, where you have this fragmentation and isolation over a greater period of time, you could also expect greater population structure. And so this was shown in Marie Vance's work with subalpine larch, where you can see that we are getting some population structure within BC and across the Pacific Northwest. And the same is true for geographic barriers. Anytime we have something that's preventing gene flow between populations, you would expect to see greater population structure on a finer scale. And so this was shown in Colin Mowney's work with lodgepole pine. And so earlier I showed you a different set of markers. So this is actually looking at markers that are linked to a gene. specifically autumn cold injury. And so this is looking at allele frequencies across that gene. And so you can see these two clusters emerging. And if you can tell that that's a map of BC, and if you're familiar with the geography, you know that these are the Rocky Mountains. And finally, mitochondrial markers may also reveal finer scale. And this is down to the fact that seeds tend to stay closer to mom. And so as long as you have differences between moms, you would be able to pick up some more structure. And this was shown in a study on ponderosa pine, where again, we're seeing pretty broad scale structure. So we're not getting down to the nitty gritty of exact provenances, but you're still getting structure within states even in the US. And so the takeaway from this is that any provenance ID would take investment in time, technology development, as well as finances, as always, especially when we're talking about genomics, and that the accuracy of ID would be highly dependent on what scale you're interested in, as well as the life history. But as we know, genomic technology has been exploding. And so as we move forward in time, we're going to have increasing information and insight, and the cost of that is going to continue to decrease. And a great example of this is the possibility of using adaptive markers. And so traditionally, population assignment was done using markers that are located in those non-coding regions, or neutral markers. And this is because these markers are not affected by natural selection, since they don't code for a phenotype. And so this is what's usually used to look at demographic processes like migration, population size, and population structure. But if what you're interested in is where your sample came from on the landscape, then adaptive markers could reveal this finer geographic structure. That's because adaptive markers are going to be linked to the environment, which we know varies on a fine geographic scale. And that's why when we saw the work by Colin Maloney, when we're looking at these adaptive markers, so genes that are related to a phenotype, we saw that finer scale. So SNPs are your friend if you are looking at species that have very low population structure. We're also seeing advances in assignment methods. We're moving into machine learning, things like random forest. Before, it was literally calculating similarities in allele frequencies or using other methods that might have had some underlying assumptions. But machine learning is going to help us parse out those fine scale differences between populations. And so the caveat is that, yes, it will cost money now, and yes, the accuracy may be low, but as we move forward in time, the investment will decrease and the accuracy will increase. And so with that, you guys can catch me. I'm also only staying for lunch, but feel free to reach out to me. I'll be in Vernon next week as well.
We have one more short presentation before lunch, and that's Dr. Nicolas Feau from the Canadian Forestry Service.
I was gonna say, if anyone online wants to ask any questions, I'd type it in during this meeting, and then we'll stop the recording shortly after. But if there's any questions, we'll try and get to them just before lunch for a few minutes.
Is it possible to have the sound on the computer? The video has some sound.
Yep, it should. Just let me know when you're ready to play it, and we'll.
Yeah, that's going to be in the middle of the presentation.
I'll just have to turn that thing up.
It's a lot of things.
Oh.
It's okay.
Do you want to play with that?
Huh? No. It's my little pet device.
So just throw this thing in here.
Yeah.
Throw in your pocket or something.
Yeah, pocket. Okay, can you hear me? Yeah. Okay, so I'm Nicolas Feau. I'm a research scientist at the Canadian Forest Service, forest pathologist. But today I'm not representing the Canadian Forest Service. I'm representing the lab of Richard Hamelin at UBC. Because all what this demonstration about a PCR portable device for pathogen detection was developed by a postdoc in Richard lab, Arnaud Capron. So if I say any mistake, it's not on me, it's on Richard. Okay, I'm just gonna give a short overview about what is a PCR and a real-time polymerase chain reaction in the context of pathology, plant pathology. It's a technique sensitive and specific for the detection of pathogen. So you have a plant, you want to know what pathogen you have on this plant, what disease you have on this plant, you can use this technology to have a very specific response. And for that, we are using the DNA of the pathogen that we target. So this is very sensitive because the PCR techniques, to explain it simply, is a photocopy of a DNA fragment, what we call a gene. And during the process, during the PCR, we get million and million of copies of this gene that then we can visualize with different techniques. This is also specific, species-specific or pathogen-specific, because we target with one PCR probe, one gene that is specific to the species of the pathogen that we want to target. The problem with PCR is that it requires technical expertise and a certain level of lab and consumable equipment. You probably all know about real-time PCR with COVID. Last year, 1 year ago, when you want to take a plane, take a flight, you had to show the results of real-time PCR. And in Canada, in Vancouver, it costs about $150 to $200 for a test. There's some good reason for that. So companies make money, but also they had to run that fast, 24 hours, 48 hours sometimes. Takes technicians, take lab equipment, all of that is expensive. But there's some way to simplify that. And one way to simplify that is this portable device. It's a PCR machine. So this is the exact same one that I have here. We can put it into a backpack. We can go into the forest. We can go into, after a day of field work, go in a motel room, and we can run a PCR in a couple of hours and have the result of a pathogen identification. This is the demonstration that I'm going to do today. So we call that point of care or field PCR testing. That doesn't require the level of technical expertise that you need to do a real-time PCR in a lab. Only a few minutes of training. And this machine works with consumables that are ready to use. They are lyophilized, so they can be kept at room temperature, put in your backpack for all the day, they will still work. And this is because there have been a lot of work upstream to that, to develop and prepare the probes that you're going to use into the machine. So now the point of my presentation is to do a demonstration with that. So I picked some probes that were ready in the lab of Richard Hamelin at UBC, and there were another's root disease probes. So some probes to detect fungus that we call Heterobasidion, that is responsible of root rot of conifer in BC. So in BC, see the pointer? Yeah. In BC, we have two species, one main species, which is native, Heterobasidion occidentale. And we have a second species that have been detected in BC, introduced probably by accident, Heterobasidion irregulare. And this one, so is exotic, it was introduced, and is suspected to be invasive in BC. So that could be a problem in forestry. The problem with now these two species that we have is that if you look at them, they are very similar. And I can bet that the best forest pathologists in the world, seeing these two folding bodies, couldn't recognize them. So at this point, you need to have a molecular test, a PCR test, or any other type of test that is not based on morphology. So now this is a demonstration, and the problem is that I have only 10 minutes to do that. PCR process with this machine takes 2 hours, 2 hours and a half. So I found a trick to still do this demonstration. I cannot do it right now. I just make a small video with some time lapse, and I'm going to play that now. Maybe.
Welcome in my lab. today my lab is actually my kitchen at home. I'm gonna do this demonstration of PCR experiment here in my kitchen. To do that, I need the portable device, which is connected to my cell phone, pipette, few tubes, and this sample of mushroom that I want to identify. So this is a two-step process. The first one being the extraction of DNA from the sample, and the second one, which is the real-time PCR. So to do this DNA extraction, I collect a little bit of this mushroom sample, just a tiny piece that I put into one of these tubes, like that. And these tubes are preloaded with a DNA extraction buffer that is processed into the PCR machine. So to start the PCR machine, I do that with my cell phone. Then I connect the Bluetooth. Here we go. The machine is connected to the phone. And I have my tubes into the machine. And I can start the run when the lid is closed. So the DNA extraction process is a 10-minute process that is done at 95 degrees Celsius.
Dirty laundry.
Yeah.
Okay, now we are done with the DNA extraction. Everything is okay here. Yeah. I can take the tubes off the thermocycler. And now we have to do the PCR, these tubes with the different probes. So the probe for Heterobasidium irregulare, the probe for Heterobasidium occidentalis, and the last probe, which is for the genus Heterobasidium, which is a kind of control. So what I'm going to do now is to pipette DNA that is extracted into these different tubes. Sometimes these tubes are hard to open. Then I put these tubes into the thermocycler. And we can start the PCR. I connect the thermocycler, the PCR machine, to my cell phone. Few steps, and I can start the run.
Still some issue with time lapse.
Okay, the PCR is done. We can take that out. And on the app, we have some curves, which mean that some DNA was amplified during the PCR. We can look into that now.
Okay. I can turn that. Okay. Yeah. So this is what I have on my cell phone. Actually, this was this cell phone. So this curve, I just gotta give a couple of explanation about that, about the result, because again, it's a demo. So, so this is what the output gonna look, and what we have in a real-time PCR when we get a positive result are exponential curves like that, who give a quantification of the DNA that we amplify. So we have three probes. The one that targets Occidentale, the one that targets Irregulare, and the one that targets the genus Heterobasilium. What we see is that we have two positives. Occidentale is positive. We detect and amplify, we amplify and detect the DNA of this species. So my sample is Occidentale. And this is confirmed too because the probe for the genus Heterobasilium has also a curve, exponential curve. It's a bit lower for some reason. I'm not a great experimentator. I don't pipette very well. So I probably put a bit less of DNA into this one. The last one, Irregulare, we have a flat curve all along the PCR, which means that we don't have any DNA of Irregulare into my DNA sample. And we are happy with that because we didn't detect the invasive species, and the mushroom that I have is just the local species. I can carry it all over the place, no problem with that. So now my take-home message is that I did the demonstration with one species, with this Heterobasilium root rot, but in Meland lab at UBC, they develop many assays for pathogen. One of them is for the genus Fusarium, for example. And you can see, and some of these assays, this one is not transferred yet, but some of these assays are transfers into probes that can be used into that, and Fusarium could be one of these. And you see some application with that into the conifer seed world and the nursery, the tree nursery world, is that that could be used in situ, so in a nursery or in the field, to detect Fusarium or other seed and seedling species pathogen, so on seed, on seedling roots, soil, water, wash out of styrofoam blocks, for example. It just once the technology is developed for the PCR and transfer onto this machine, there's that open the door to many other applications that could even be used in operation. And I think that's it for me.
Thank you, Nico.
No problem.
That's the end of the program for this morning. I'd like to give a warm thank you to all our speakers, and especially Melissa, who took care of all the magic with the Zoom call. So lunch is served. Please help yourself. We are going to